The balance looks about right. Okay. I'm gonna wait till I see the stream running up on my right hand screen. Alright, we'll do a quick audio check. Audio check met my standards of acceptability. Alright. Just do the old, I put Discord into stream mode before I accidentally show something I shouldn't. There's a button to do that. Streamer mode on. Cool. Alright, here we go. So, what is the goal? The goal is to develop a client for the game Harmony. For those who are not aware, Harmony is a game developed by myself and one Sasha Bear. The game is quite a simple one. In Harmony, you connect stones with lines. If lines overlap, they eliminate each other. Lines can... If there has to be at least one space between two stones for there to be a harmony between them. Cages, or zero-width harmonies, occur whenever stones are adjacent, and adjacent stones basically have no harmonies within them. If any one of them is considered dead, all the stones in the group are dead. Now, this is what like a small end game state might look like. Now, the goal for me here is to develop a generic harmony client, taking advantage of affine types. So, first thing we're going to do is make this thing a library, which I think all I have to do is call this lib.rs. Okay, so we have our core game Harmony that I don't know what's going to be in there yet. Cool. I'm also going to have a move, and then because I'm doing affine typing, there will be move place, and there will be move from, and there will be move. You know what, let's not call it move, let's call it act. And there is act place, act from, how should I name this? You know what, let me have a look at how Diesel names them, because Diesel does this a lot, where basically statements are incomplete. Okay. You know what? Let me zoom in a bit. There we go. Maybe one less. So we have action move and action move. We'll call this action move from, act move from to. Okay, and then I'm going to have some kind of a marker trait called completed action, which is implemented act move from to and place. Okay, we will get back to these implementations later. For now, these are just marker implementations. Okay. Right, and then what I'm going to do is configure a test or tests. create our tests library. Stub test is it builds. Okay. And then we will test that. We should find that it does build, in fact. Okay. And it builds. Wonderful. We'll come back to our tests later. Right. Now, I don't know what's going to be involved with this Harmony structure, but I'm expecting I'm going to be taking mutable references to it a lot. Now, I know that act, I expect to have a way of returning act place and a way of returning act move. Now, act move from starts storing data, and the data it stores needs to be a point, which I'm going to call location. Now, locations have an X and a Y, and now I can say that we also have here a size X and a size Y, as I think it's fair to say that our board will be being initialized with these, and we will also need some backing data. And we're going to need to represent stones, which can be black or white. Could enable 3-player variants out of the gate. You know what? We'll call this variant, and we will create pub trait variant, and then a variant needs to have to be able to display all of its variants. You know what? We'll worry about making it generic later. For now, we store a vector of optional stones. Now, this will get null pointer optimized, in theory. If I were to do a set of RC stones, but I think for now I'll just leave it as stones, and I'll make sure that this here is declared properly. Partial hash. Right, let's go slap this on everything that can realistically have it. You know what? I don't know if we'll need hash yet, so we will take hash away. This here is definitely copy compatible, as is act, because act doesn't actually have any data. As is act place, because act place will have some data. Act place is going to have a point location, and you know what? We're gonna do some fun things here. Are we in 2018? We should be in 2018. We are in 2018. We're gonna say that we location usize y usize. We're just gonna give ourselves a stock constructor. But I'm also going to do a macro, which is macro rules lock. Actually, do I want to do a shorthand for it? It'll be quicker than, yeah, I don't want to have to type location.no every time, which takes in a x expression and a y expression, and it returns location new xy in place. Use create everything. Fn location declaration. Okay, let's test our location declaration code by saying we will say x equal 8, y equal 5, and we're going to say that assert ec. Can assert ec take in more than 2 things? That's a great question. Looks like only 2 expressions. That's fine. So what we'll say is we'll say location equal location x y, and those are copy safe, so that's not going to cause any problems. And then we're going to assert that location is equal to lock xy, and we're going to assert that location is equal to location new xy. This is all trivial, but it's just about getting code coverage. And there we go, we get an error. Typo should be lowercase x. Okay. We need to come back over here and get this moving. So act move. Act move from stores a location. And act move from to stores a from location and a to location. And you know what, for now we'll just make them public. Act move is going to have from L from location. Why does my Haskell code look some of there's supposed to be a new line in there? Where is there supposed to be a new line? Gordon Dunn. Also, hi. Member of the CDN that I trust. Enjoy being modded so that you can keep an eye on my chat when I'm not watching it. From location to act move from. Act move from. Okay. What don't you like? Line 41. Act move. Act move. This just returns act move. Because the whole point is to just have act, place, and move. Right. Missing fragment specifier. Oh, wonderful. We've got things that I haven't learned yet are no longer legal code. Let's quickly find out what's broken. Okay, cool. Move. Ah, of course, I can't use move because move is a keyword, except I can because I can do this. Do I really want to do that? That's like a bad solution. I did like your meme, John. Gordon Dunn. Debating. So the logical thing to name this is move. Do I name it move with a raw identifier? Or do I not name it move? You know what? I can call this from. And have it go straight to act move from and cut out act move entirely. I think I like that more. From L location. And that way I don't run into any keyword overlapping. And then I can just call it act from and act to. So act from, from, and I call this from, and I call this place, because let's be real, act place needs to have a place in it. That is a location. Place. Do you want to build this now? See where our errors are coming in. 3 errors, cool. All macro errors, maybe? Act move from to doesn't exist anymore, of course, because this is act from to now. And we'll get to what this marker trait means in a bit. For now, it will just be a marker trait. Cool, figuring out what macros do now, because they changed macros. Missing fragment specifier. It was previously accepted by the compiler, but it's being phased out. For more information, have a look at this Rust issue. Hello, this Rust issue. Let's have a look at you. That's just VS Code being a pleb. That's what I want. Really? Let me just grab that manually. We can go have a look at it. Missing fragment specifier, future compatibility warnings. Macro rules. Oh right, it's just I'm a pleb that doesn't know how to write macros properly because it's $x colon expression $y, and then I do $x $y, and now it builds, right? Now it builds, wonderful. And now if I do cargo test, and I make sure that everything that should be public is public, so that it builds. Okay. Cannot find lock. Do I have to do macro export still? I need to revise what the macro changes were for the 2018 edition. Rust 2018 macros. Macro changes. Procedural macros. Create prefix. Okay. I still need to declare them as export. That's fine. Alright, that's how we do this now, and then this compiles. No. It's just my inability to write good tests. Okay, you know what? We're gonna call this 8.5 and this location 8.5, and then we'll take two more random numbers. We'll call it location 682. 682. Both of these should work. Oh, of course, and I can no longer use shorthand specifier because I'm not calling them X and Y anymore. Okay, let's just format my code real quick. Okay, cool. Now it's readable. Okay, the reason I have a lock macro is because we'll be talking about locations a lot. I could make a location bounded on a client, and then, no, you know what? We'll just build in that into our error system. Okay, so now we've got a way to represent all of the objects, and they come in a very affinely typed way. If you don't know what affine types are, it's basically where your type system encodes a lot more information than it would otherwise. So what I'm going to do is I'm going to check act place works, and I'm going to say assert act place at place lock 7.2 is equal to act place lock 7.2. Okay, that should pass. If I could spell, which is a big gamble, you know, me being able to spell. Cool. And then we will have create act move, and we're gonna assert that act from to from lock 8.6 to lock 8.12 to keep it plausible, because they will be in the same line usually, is act from lock 8.6 to excuse me, thing that returns act from to is named wrong, question mark. Act from to. Oh, nothing exists for act from to yet. Act from. Implement act from fn2 takes in self as mutable location takes in 2, returns act from 2, self.from 2. In fact, you know what we'll do is we will call this act from, and then we can just say from 2 in here. And that should build right? No? I might have to say from, which is not very pretty, but... No, how does struct destructuring work? Hi, Bork. Hello, refreshing my memory. Rust struct destructuring parameter. Hi. Destructuring structures. Okay, like exactly how one might expect it to look. Why is this not right then? I'm saying destructor act from as from, which gives it the type location automatically. Right? I guess I mean, it still needs self technically, but is there a way to destructure self? Let's look that up. Rust destructure self. Is it possible to destructure the self argument method? This was originally intended to be possible with universal function calls, so it's backwards incompatible. So it would mean that bar and self are suddenly equivalent to fn, which will break. Okay, we have to do an explicit destructure. I'm okay doing an explicit destructure. Right. And then here I say act from 2 to get it to build. And this is act from. Cool. And then we make 2 public, and then it stops complaining about it not being used, and it works in our tests. If I can type properly, and I'm also going to reformat my code. Cargo test. Ah, wonderful. Errors. Love errors. Things not implementing debug. Okay, you know what? Let's go right now and make not having debug illegal. Deny missing debug implementation. Right, shout at me if I ever forget to copy this line onto literally everything. Act from should be all of those things. Act from 2 should be all of those things. Previous error. This function takes 1. That's because over here I haven't actually said what the location for this is yet, and it is 812. Cool, all tests passed. Cargo, format, and we'll build it and we'll check for warnings. No warnings. I can't spell. Apparently my missing debug implementations is wrong. Okay, we're also going to deny missing docs. And we're going to start documenting the whole way through. Represents a single placeable stone. Okay, right. I've actually watched my code. Don't feel bad about speed of code. I've been, like, it's 4:15 in the morning, and let's be real, everyone's best code gets written at 4:15 in the morning. Represents single placeable stone on the Harmony board. Represents a Harmony board and the internal state of the game. Okay, now we're gonna do a quick implementation on this. Implement Harmony. New. Returning Harmony. It takes in a size X and a size Y, and it returns harmony size x, size y, and then data is equal to vector from iter. They added a new feature in the newest Rust edition where you can create an iterator from a function, I believe. Let me check that, and we might have to wait on my Rust to update quickly. Rust iter. You know what? It was on the Rust subreddit. Iter from FN. Which version did this sneak in? 1.34.0. What version are we in right now? 1.33 nightly. Okay, Rust update. Okay, we're gonna have to wait a minute for Rust to update to get me the latest stable and nightly versions, because that is absolutely something I want to use here explicitly. I mean, here explicitly I could express it as 0 to size x times size y, map, discard that, none. Like that there is a perfectly valid way of writing this iterator. But I don't think it properly expresses what I want it to express. Like I could also say, so just take size x times size y is better. I think that works. That should be a universal iterator. While we wait for my Rust to update, we can have a look at this over on the Rust playground. Because if I in here say for x in dot map underscore none take 8, this should print none 8 times. Map not found for range full. Oh, wonderful. Firefox is not responding. It's because I accidentally hit save. This works. Into iter not found for range full. Is range full not already an iterator? I would assume range full is an iterator. Following range full does not implement. Range full. Oh, okay. Iterators have to have a starting point. So this is the go forever iterator. And so this should print none 8 times. Cannot infer a type for T. Right. Of course you can't. This should output some 7 8 times would be a more apt way of saying it, yeah. Now the question is, do I like this syntax more? Or do I like in iter from fn use std iter? Ooh, interesting. That I have to be careful of, because this would actually need me to say some 7 in order to get the same result. Okay. That changes things actually, because iterator from function expects a function that returns, of course, because it has to return the end. Do we not just have a go forever iterator yet? Like a nice abstraction around the idea of do this for as long as I tell you to. From a fan, repeat. Create a new iterator that endlessly repeats a single element. That is exactly what I want. When has this been in Rust since? When did you get added? 1.0? Huh, cool. I just didn't know it existed. So what I actually want then is iter repeat some 7. Yeah, okay, that second style is definitely the style I want. Okay. So here I'm just going to say repeat none. Take size x, size y. Okay, and so the goal here is to allocate the entire vector up to the size that it needs to be allocated for in order for indexing to happen against this size, and then size is immutable after the point of creation. Clear is going to be self.data is equal to, we reset it by doing a new one of these. Okay, so now we have a way to also clear the board. Okay, and then what we're going to do is we're going to have act. And act takes in A, where A is a full action, is what I'm going to call it. Okay, so place, now this here has to return a result of some kind. Now our OK type here is just whether on our OK type here is just unit, it's just you succeeded. Our error type here is what needs to be more expressive. And we'll call this action error. And we'll make a new action error. Okay, what kind of errors can we have? So, and you know what? I think full action should actually specify its kind of error. That way we can do more specific error handling on each of them. So this here is going to have an associated type action error. And then here I can say type action error equals act from to error. And then here I can say type action error is act place error. Okay, and now act from to. What can go wrong with this? Well, first of all, we need to declare act from to error. Now I also should implement the error trait on this, so let's go make sure we do everything required to do that. Which is this thing here, std error error. Now what error error expects is the ability to report the cause of the error. No, we no longer need to implement the cause, we implement the source instead. In fact, what's actually mandatory in this? Nothing. It's just a marker trait. But we can report a lower level error if we want to, which we probably don't in this case. Okay. In that case, implement error for act from to error. And we specify that this thing has to be an error to be valid. Okay. Now, act from to error has got a few different error states. Namely, it has got right. Let's see. Well, you can only act on something if it's your turn. So, target not of current turn. That's going to be a pretty significant thing. Or from stone not owned. Better way to express that. And then there can also be target not perpendicular. Or orthogonal. What word do I want here? I'll say orthogonal. Target not orthogonal if you try to move in a non-diagonal direction. Or it can be blocked, path blocked by location. Blockage, blocked location. Okay. I think that's a reasonable structure for this thing. Now, we should probably give this a slightly nicer display, which I believe is a thing that the error trait allows us to say. Description, yeah. This method is soft deprecation. Although it won't cause compilation error, the new code should use display. Instead, a new implementations could omit it to obtain... Oh, does it just call the display method? Oh, it literally just tells you that description is deprecated, use display. Errors must describe themselves through display and debug traits. And okay, so we need to do a display implementation for it. Okay, and now I think it's time for me to create an act folder. Mod.rs. And start moving some stuff out, because act here comes into this module. Okay, and then up here I say pub mod act, because it's just going to be re-exposed. Okay, and then in here I'm going to use everything in act. In create act, because I like using full specifiers. Okay. And we also need to use std iter repeat. What are you shouting at? Unused import. Publicly re-expose everything inside of act, please. Okay. Now in here, create a new file. Act place.rs. In here we have pubmod act place. Use act place everything publicly to re-expose them. And then from our library, we're going to copy over all of our act place code, which I think is just this. Oh, and the error. Act place error. I haven't actually done that yet. That's still stubbed. Okay. I think the idea of a full action should be in here though. Okay, and now I need to pub mod act move, pub use act move everything so that it's re-exposed, and create act move, and then grab act from 2, act from 2, and act from 2 error. And we'll just shunt them all into act move. That error should go away once it catches up with us. Okay. And then finally, location, which is all of this. We can create a new file, location.rs, dump that in there. In our library, pub mod location, and then we want to pub use create location. Just re-expose everything from in there. It should reformat these together because of how I have my reformatting configured, but who knows. Okay. Realistically, I should pull stone out as well, even though it's a trivial struct. Now that we're doing this refactor, pub mod stone, pub use create stone, everything. Okay, who says you can't do productive code while you know, wait for go for the restructure. Right, now I am just waiting for this to finish sorting itself out with grabbing everything for me. Right. Find size X, size. Use std error use crate location. Use just the entire crate, to be honest, in all of these. I'm not faffing around with manually making sure everything is okay. I'm just gonna tell it to use the whole crate, I think. Okay. Because of these, I re-expose everything that matters. Right. Okay. We can write Harmony. Harmony is a perfect zero-sum perfect information abstract strategy board game for 2 players. This library implements the core functionality of a Harmony client that can then be used in providing useful abstractions for modeling the game. Cool. And now I need to document each module. So this is the test module. I don't need to document probably. The stone module I probably do need to document. stones can be either black or white and are placed onto the board. They are represented by Rustdoc comment link question mark. There's a proper way to do this. Represented by stone, which is enum.stone.html. Can I do create stone? That really is the question, because that's really where we're at, to be honest. Or I guess it would be more accurate to say create stone. We'll see if it likes that later. These should all have these going at the top of them. Okay. Location. Used for modeling arbitrary positions on a Harmony board. Locations are arbitrary positions on the Harmony board. Represents a single location on the Harmony board. Constructor. How do people write boring constructors when something is just constructs from parameters? What is an example of something that constructs from parameters a lot in Rust? How do they write documentation for that officially? Also, I've got too many things open. Where's my dashboard here? Cool. Okay, so it generally constructs a new location from parameters. Okay. Okay. Shorthand constructor for locations. Might as well write a quick documentation test. Rustdoc assumes this by default. Block. Do. doing inline testing is probably a good idea. Do I like doing this? I don't know, I'm kind of on the fence about this feature. I mostly don't like it because I don't have syntax highlighting for it. Let's leave our documentation vague for now. I need to write good documentation. Represents an action. Affine type. Affine starting point. What's the correct place to refer to one of these? Let me look at the wonderful Wikipedia article for affine types, which is really what I'm going for. Affine types are a version of linear types allowing to discard a resource. There's a fantastic write-up of Rust's affine type system somewhere. It's this one here. Uses what are... Wait. It might be this. Ah, yeah, of course. I need to remove copy from my affine types. Because they should never copy, they should move. It's linear. Used to construct as a starting point for constructing actions. Let's think. So linear types can be used a number of times, can't be used more than once, must be used at least once. Okay, yeah, we can tack unused must use onto these. Unused must use, right? Right. This is basically to... I mean, Rust pretty much has got linear types. Which is the goal here. They're just not strictly like the fact that you must use exactly once isn't strictly enforced. But what I'm doing now is linting this with unused must use, which means if anything ever shits out an act, there is a strong incentive to... And you know what? I'm going to tack self onto these so that they're called with act dot rather than with act colon. It might seem a little bit unrustish initially, but I think it makes the entire thing a bit cleaner. Must use. Okay, I'm pretty sure must use is the annotation I want for it. Okay, and then a full action specifies for now just that it has an error type. Okay. I probably should do field... I only need to do field documentation on public fields. Okay, so this here creates a... This is Rust, the programming language. Gordon Dunn, I'm aware your question is rhetorical in nature, but I thought I would answer. I am probably going to end up throwing this on YouTube. Or at least trying to preserve the VOD. I don't actually know if I'm set up on Twitch for Twitch to save my VODs. I assume I am, but they changed the behavior a while ago. Let me go investigate that real quick. Videos, channel settings, automatically save past broadcasts for up to 14 days, 60 days for Twitch Prime users. Okay, so I'll have a month to figure out to get the VOD up on YouTube. That's plenty of time. Okay, creates a placement action, creates a movement action, begins to create a movement action. This requires a subsequent use of 2 to enforce to complete. Act.from lock 7.8 .2 lock 12.8. Okay. And then you know what? Just because we can, let's give ourselves a nice from 2, which would be a full one. Creates a full movement action. Okay, pub trait full action, cool. Act move. Movements represent the process of taking a stone and moving it to an orthogonal location such that it does not pass over any other stone. Okay. Act from is an incomplete action with only a starting type. This is all the time. Must use with only a starting location. The stone to be moved. Act from lock 8.9. Requires a call of 2 in order to complete. Do I allow from and then 2, or 2 and then from? No, for now I'll leave it as from 2, just to enforce it, because if someone wants to shortcut it, they can use from 2 instead. Which is what I just implemented over here. Okay, act from 2, a complete movement action from the starting location, of the action, the stone to be moved. The target location of the action where to move the stone to. Right. Cargo test. Let's just, I'm expecting tests to fail because I've been doing a lot of stuff in the background. I'm also expecting it to shout at me over missing documentation, but that's why I'm documenting things. Represents the possible errors that can arise from a movement operation, from a movement action, to keep our action movements consistent. The stone being moved does not belong to the player whose turn it is. Okay, and now over here in the Harmony model, we need to store active player now, because that's something that we are saying is going to be meaningful. And active player starts as black, as is tradition in Go. Okay. Oh. Bit of Devon Townsend in the background there. Okay, let's fix some errors. Right. Error not found in scope of act move. Use std error. Act place error doesn't exist yet. Should probably make that exist. Act from 2. This is also must use. Errors are automatically going to be must use because they get spat out by a result. Okay. Pub struct act place error. Except it's an enum. Things that can go wrong with placement are placement outside bounds. The placement is outside the boundary of the board. Placement on stone. Stone location. The placement is at a location already filled by a stone. Both location and stone are copy safe, which means that this is, you know, having these owned is a same thing to do. And you know what? We know the location, so it's just about letting them know what color the stone is. Which, to be honest, I don't really need to do, but I'm going to do it anyway. Right, time to do some more error chasing. Right. Line 42 of which file? Mod.rs, which is in here. Line 42. That's because this here is going to come out to be in act place. Full action for act place error. You're going to come out to be an act move. And then act place error here. Error for act place error. Get that marker type in there. Marker trait, so it knows it's an error. Okay, 3 errors. Action error cannot be found in this scope. That's in lib.rs. Here. We express that a full action has an action error like that, so it's now a action. Okay. I want black and white to be usable outside of their stone context. So what I'm going to do is I'm going to say inside the stone library, we pub use the contents of stone, and now black and white are exposed. Okay, error is not found in act place. That's because I need to, up here, use std error. Okay. Error doesn't implement debug. Ah, that's because I haven't also, why you copy, you are I mean, you are copy safe. But I want to move you. It's one of the rare instances where being copy safe isn't actually the metric by which you decide to implement copy on something. Okay. The trait display is not implemented for... Okay, we have to implement some display here. Implement display. Use std fmt display. Act from to error. Use std fmt formatter. Use std fmt result as fmt results. Okay. Okay. The stone being moved to a location which is not orthogonal to the starting location. Another stone lies in the movement path of the stone. The stone color of the stone blocking it. Okay, so we're gonna write to F. In fact, we're gonna match on self onto error from stone not owned. We're gonna write onto F. The target stone being moved does not belong to the player whose turn it is. Oh, hey, long strings. The stone being moved does not to the player whose turn it is. Act from to error target not orthogonal. The stone being moved. The stone that is being moved is a destination not orthogonal to it. Act from to error path blocked by. And you know what? We will forward the location just so that we have access to it here. And you know what? Here, from outside bounds, no stone exists at the location being selected, or it is out of bounds. Because I'm gonna flat map, so no stone exists. No stone exists at the target location, or it's out of bounds. Stone being moved does not. The stone that's being moved has a destination not orthogonal to it. No stone exists. Location. Location. Belong to from stone not owned. Stone being moved does not owned by stone. Okay, let's go implement display for stone real quick because we're going to need it. I wish there was a helpful way to bring in the stuff you need for a format implementation, but there just kind of isn't. You just kind of have to grab all three of these. Implement display for stone. That's what it looks like, right? I do it enough that I should know what it looks like. From and self with a yeah, cool. Match self, black, right onto F, black, white, white. Okay, I'm also gonna implement the not operator on this because there's a trivial conversion here. Use std ops not for stone. Type output equals stone. Fn not on self returns self output of match self white to black and black to white. Okay, just because I'm going to use that down here now in here, stone being moved belongs to it is turn. Okay, and then lastly, target not orthogonal. The stone that is being moved has a destination not orthogonal to it. From location to location. From to, and I can say that the location, the stone's location is not orthogonal to its destination from to. Need to implement display for location now. Implement display for location. Fn fmt self fm formatter fmt result. Right onto F in parentheses a comma separated location self.x self.y. Do I want to... No. Yeah, style-wise... just going to do this to show that this does a... Wait, no, because we don't have move access to self. The reason I can... Yeah, no, brain. Only do that with affine type, with linear types. Only got one error. That's a fun one. Because I don't have a comma here. Okay, path blocked by... the stone's movement path is blocked by the stone at... And path blocked by has got color and location. Color, location. Okay, errors, let's go. Act place error does not have, okay, placement outside bounds and placement on stone, and location. Color. The placement is location already filled by stone, the placement outside, okay. Grab our display. Implementation. Now that you have the Harmony board, where the Ouija board, unfortunately, contacting spirits is outside the scope of this project. Implement display for act place error. This should be way down here actually. Okay. And then act place error is that's FN, FMT, F, and mute. Self, F, and mute formatter. FMT result. Right, F. No. Match. Self. Oh, by the way, some people might be wondering, self here is a reference. Why do I not have to say placement on stone like this? They implemented automatic dereferencing for matches, and by that I mean automatic re-referencing. It's a bit of a mess. But it makes the code shorter. Basically, this here is implicitly equivalent to this. Now you can see why for new programmers it's much nicer to just write this and not have to worry that it's all auto-referencing. But you can also see why a lot of people that were used to the old system prefer it, because it's more explicit. Placement outside bounds is actually the first one. And then that, I just care about the target location. So match, self, act place error, placement outside bounds. I'm missing a comma up here. Right, F, the location is outside the boundary of the board. Location. Okay, and then act place error, placement on stone, color location. The location already contains a stone. Location and color. Okay, next error. Down to 4 errors. Act place error doesn't implement debug. My bad. Also, act place should not be copy because the goal is for it to move. This might just build now. But that's a bunch. Errors. Implementation of not is missing for and stone. Oh, you know, that makes sense. So here is the fun thing. So you know how that thing I was just talking about, where this here is implicitly doing this, which means that owned by is a reference, despite the fact it might not initially have looked like it is, because this looks like a kind of owned destructuring. Because it's an implicit reference, this doesn't work. But it's fine, because owned by is also of type stone, and stone is copy safe, which means that I can just put an asterisk here, and that error will go away, and we'll go down to having one less error. 7 errors. I know it says 9, but the 8's gone down to 7. Right. Okay, and now we have errors in our tests because I changed act to be a dot specifier rather than a... I made act use instance methods rather than static methods, even though it has no internal data. Why did I do that? Because I like it better this way. Okay. Act doesn't return. Okay, wonderful. And so now it comes down to the definition of full action, which as far as I'm concerned just needs to say apply action self, which is affine, or linear rather, therefore we can safely move it, or it's intended to be moved even, onto the Harmony board. And return result, return a result action error. Right, that's the structure we want to take with this. Okay, and then over here in act from 2, I'm just going to quickly make these a stubbed implementation. And then in act place, okay, and now in the library I can here say when you call act on Harmony, and also new is public, clear is public, act is public, we can say action.act apply action self, and that should just work. Alright, errors, let's go. This function takes one parameter but two parameters were supplied. That's because these should be, that should be a multiplication. Next. No associated. Oh. Okay, that's that error fix. Just didn't have a thing in scope. You need to be a multiplication. Okay. Cannot find type action error. Interesting, that tells me that action error isn't being properly re-exported. No, it tells me that this should say self-action error, and I'm a numpty. Okay, that should be that error fixed. Okay, and then you need an exclamation mark after you because you're a macro. Oh, argument must be a string literal. But I mean, technically, this should just this code would optimize to be valid, but for the sake of keeping the compiler happy. Like it's just going to convert what I wrote into that at the point of optimization, because string literals are more efficient, so it will unpack it to use string literals. But Rust doesn't make any optimization guarantees except for null pointer optimization, to the best of my knowledge, and therefore the compiler requires me to write proper code, which is fair but also annoying. Act. Okay, here we go. So Harmony. Construct a new Harmony board with a given dimension. With given dimensions, probably a better wording. Clear. Reset the Harmony board to have no stones placed. Apply a completed action to the Harmony board. Okay. Missing documentation for variant. White. A white stone. A black stone. Real detailed documentation right there. The Y coordinate. The X coordinate. Again, real specific documentation right there. Applies the action to a given Harmony board. Missing documentation for an associated type. The type of error returned by a given action. Missing documentation for trait. Represents a full action which can be committed to the Harmony board. You know what? In my library, I'm going to rename this from act to commit. Okay. The color of the stone blocking it, the location, the color of the stone blocking the movement, blocking the movement. The origin location for the movement, the destination location for the movement, the ownership of the stone that was selected, the location that was selected. Two. Completes the action type by supplying a target location. Location. Here, the color of the stone being placed on, the location of the stone being placed on. So one thing that Rust will do with the setup I've got is teach you to document your code as you go along. The location of the attempted placement. Missing documentation for enum. Act error. The set of errors producible by a placement action. A complete placement action. This attempts to place a stone at a target location. Oh, hey, you know what? It's not, though. Because act place should have a color only. And then pub struct act place at should have a color and a location. To be honest, when you're using linear types, types kind of are documentation enough. Rename symbol, act place at error. Okay, that is a valid left-hand side, right? Oh, let. Color. Stone. Color. Begins to create a placement action. This requires a subsequent use of act to complete. Act dot place white dot at lock 85 is a reasonable example of it in use. Tests.rs. Place white color white. Okay, missing documentation for location. The color of the stone being placed. The location the stone is being placed at. Haha. Which adds a new error, which is that placement out of turn. The color of the stone being placed is not of the current player's turn. Placement placement out of turn. The color of the stone being placed, color stone, and then down here I have to handle act place error, placement out of turn, color, right F, a stone of color is being a stone of color cannot be placed on turn. Color. Missing documentation for struct place at. A complete placement action. the various kinds. This module contains the various kinds of actions that can be performed and the traits that unify them. It is important to note that actions are linearly typed and as such are generally constructed via method chaining. Okay, and then the same way we have place and place that, we do pub fm place at, self color stone, location, because in act place it's called location, yep. Act place at color location. Create a full placement action. Missing documentation for a module act place. Contains the placement action and its linear type constructors. Placement represents the act of placing a stone in an empty location on the board. Better way to phrase that. Missing documentation for at. No. Method is never used at because it should be public and then it doesn't matter that it's never used. Two new errors. Unused variable harmony, that's fine because we're unimplemented here. Okay, we should also check code coverage for the shortcut methods. Block 89.22. Test. Oh, test failed. Line 14. Couldn't compile. Why couldn't it compile? Do documentation comments not share scope? Or do I have to declare my addition? Rust documentation comments. Documentation. Documentation tests. I mean, I can just like use create everything, but I don't really want to have to do that. might literally just need to put that everywhere I do documentation tests. No? White not found in the scope. White is exposed in here. Can I... Do I need to update it? Does it need to be this? Does that work now for two of them? No? Okay. Okay. Okay, it doesn't like that trick. I think I don't want to just suppress this here. You know what? I'm just gonna assume that everyone is smart enough to know what they're doing here, especially if I change this to be okay. Path ambiguities, complex. Okay, let's just do that for now. Yeah, I'm no longer doing these. I thought I'd be helpful, but instead I'm just not. Okay, cool. All tests pass. There's my tip. Delete tests until your tests pass. No, it's just documentation tests. I need to learn how to use them properly, and this is not the time. You know, with it getting slowly light out outside. It also lets make my code readable. Hey, my code's readable now. What error does it think is in here? There isn't one. non-static lib std instead of... Some interesting error. It's probably like a nightly error. I'm just going to ignore it. It's not that bothersome. I mean, to be honest, no. This might just fix it. He's messaging me. No one important. Just more Gordon. Cool. Right. What I'm going to do, I'm going to steal my documentation specification from the one place I decided to write one, which is for my final year project for university, my bachelor's project, because it's a style I like and I should probably make it my universal style, but for now I'll just copy it over. Final year project, code, server, rustfmt.toml, copy. No, cargo fmt. Okay, and now that did fix the error I had because it has restarted with the knowledge, and now you can see it's done things like pack this down and reorder things, and it's generally nicer. Cool. Test is where I'm expecting to see the biggest changes. No? Okay, that's fair. Does cargo fmt run on the tests actually? Cargo fmt should format test by default. Need to do that. I don't know if that's the default behavior yet. I'm assuming it is. This here, it would be expanding out to be in long form. It just doesn't quite overflow, and that's, to be honest, by design. Okay. Right. Are we on to actually doing some meaningful work? I think we might be. I think I might have got the skeleton of the library done. Right. So create a new empty board. Okay. Things we are going to want. We are going to want the ability to index by a location. Now the index operation is non-failable if memory occurs to me. Oh, the index operation you can specify the output type for. Well, that's fine. Implement... Okay. First of all, use std ops index. Okay, and when I run cargo format, you're going to see how it will, in theory, if I had code that compiled, compact these down to include them both, which I like. Okay. Implement index for Harmony. We're implementing index by location. And our type output is equal to option Option and stone. Right. For harmony, do you think a good way to do this? Appease the compiler and all. Oh, wait. I'm being a dumb. Stone is copy my brain. Therefore, referencing it doesn't give us any benefits. Okay. And then what we do is we do... Stone is one of the few things I've made copy, right? Yes, good. Should be stone and location are both copy and then nothing else is, because everything else is a linear type. Okay. Self dot data dot get, and this is a checked. Get is checked, whereas indexing is not checked by default. And we want to get y times by size x plus x, because that returns a option and option. Okay, now if we unwrap that, we actually type check in theory, but that doesn't handle the case where we access out of bounds. So what I actually want to do is flat map it to itself. Right? Hold on. What's flat map called on an option? Because it probably exists. Option re-implements a lot of the stuff iterators do to be useful. And basically what I want to do is turn... calling and then on itself. Transnone is the option is might be calling and then on itself. What do you type? And then loses the reference, question mark. Yeah. Because get is giving me off a and option stone. Well, I mean... that shouldn't work. no. Okay, hold on. There's a really trivial for this that my brain is not working for. I'm pretty sure it is and then that is used for option packing. Expected type option of something. Is it really this? Because that's dumb. And then discard that. Expected type. Like, the whole thing I'm trying to do here is basically take advantage of the null pointer optimization. So this is going to return an option. A none value on an option. No, because I'm not even. I'm returning a reference to an option, which should be. Which should do null pointer optimization via asref to be either null when it points to none, or I don't know if that worked actually. Is this even a valid expression? It should be. Let's think about it. This gives us option. Yeah, so unwrapping this is valid. So unwrap or none. Type checks. Doesn't type check. Right, it needs a none to reference when output doesn't exist. Is what it's complaining about here. Okay, yeah, this isn't a sane operation. I just have to implement a get and a get mute operation. Because then I have full type control. Gets a reference to a stone at a given location. Note, stone's a copy safe, gets a stone at a given location. Pub fn get and self returns option stone. Self.data.get size self.sizey times by get expects a location dot multiply the location dot y by our size in x and then add location x. Okay, that gets an option and stone. Cloned. Of course. Unwrap or none. Cloned. Alright, cool. Cloned is free here because it's copy safe. Because anti to T is a free operation. It's not free, but like it's tiny because locations don't take up space. They're 128 bits. There's nothing. Not when we've got a big heap allocated object being accessed here that contains a bunch of them. And a bunch of them that are... I mean, it could probably compact it down. Depends how nice the optimizer's feeling. Mutably gets a stone at a given location. Harbor get mute self location option and mute stone. That's what our ideal API here is. Self.data.getMute by the same parameters. Okay, what does getMute yield? GetMute yields me this right now is an option and mute option. Okay, so what I need to do is I need to map as ref, as mute ref, and then turn none into none? Question mark. As ref mute. It's the kind of thing that might exist. Yeah. Alright, I need to go look at option documentation real quick. It's as mute. Wonderful. Right. Slightly cleaner code. By the same semantics. It's technically more proper because it then gives them the freedom to do address mutations and things, and like I'm probably going to hand this up to C, and C programmers do absolute nonsense. Yeah, I'm allowing mutability. I could make it transformation based, but when you've got a big vector, mutation is just nicer. I've thought of a thing about this API, because you should be able to set something to none, which means what I actually want is mute option stone. Do I really want option and mute option stone? That's probably actually the nicest way to do it, as much as that pains me. Because this... Right. Do I want to just do the naive wrapper? Probably. So here we do self.getMute and mute location dot map n start n dot is equal to some value dot is some. Sets a stone in a location, returns true if in bounds, returns false out of bounds, set value, clears a stone in a location. Yeah, I'll absolutely get this. Returns true if in bounds, returns false if out of bounds. Pub if an unset value, and mute self, location, location. Bool, self.getMute location dot map n is none dot is some. Okay. Cool. Got set value, got unset value. We've got get mute for give me a thing. We got that for give me a thing. You know what? We're also going to have a get value, which is an abstraction over that, which is gets the color of a stone at a gets a stone at a given location. One exists, and then that there is the nicer abstraction. Get value, self, location, location, which just returns an option of a stone. Because that one is the one that does self.get clone.unwrap or none. And this is the one that basically goes, drills all the way in and is like, hey, just give me option stone. None if out of bounds, none if no stone exists, or a stone if there is one there. Because that'll be a useful check for us in a fair number of places. Okay. Right. I think that's all of the getter and setter abstraction I need to write. Which means I think... Please compact that line down. Thank you. I think I can go into, assuming all my tests still pass, which they should. Okay, now I need to write some tests for that stuff I've just written, which... Test. Getter, setter. Let harmony equal, mute harmony equal new harmony new. Make it a 9x9. this is going to test all of our getter setters. So first check is get out of bounds, where we say let mute harmony assert ec harmony.get lock 1010, or even 99, right? 99 should give none. Because 00 to 88. That's a good boundary data test. Big fan of boundary data testing. Cool. Right, now, it occurs to me, this here, I'm just going to put in a manual bounds check. If lock.x is greater than or equal to self.sizex, or location.y, they're use sizes, so they can't be negative, it's greater than or equal to self.sizey, then give me the old classic none. Else this. Okay, and so the reason for that is that the kind of internal logic of this is not boundary checked in x and y, it's boundary checked for the equation, and so I'm manually boundary checking it for x and y, and then I'm going to run the same operation on this here, just because it forces it to reason about the locations. Because like before this here, or like saying give me the 5th 510, like those would have passed, whereas now they definitely fail. Yeah. Oh, test failed. 9-9. It should. There should be no 9-9 for this here, right? 9-9 shouldn't exist. Like you try and get location 0-0. That's going to exist. Location 9-9 should be 1 out, because it should be 9 times by 9 plus 9. Like 9 anything should be out. Oh wait, it's this one here that failed? Huh. 10-5 it was okay with. It shouldn't be. Ah, I found the problem. And that is why we write tests. Okay. Just going to repeat those for the get mutes of the world. Okay. Get out of bounds, set values, harmony.set value, or get mute set, harmony.getMute at lock, let's say like 5-5, or you know, go like 4-4 Tengen, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 4, 4 here is Tengen. And then map its internal value, if it exists, to be equal to white. Tests passed. Okay. Harmony dot get value at 4, 4 is some white. Should pass. Yep. Okay. And you know what? We will add a quick get value. We will add the get value checks on all of these as well. And then we will add a fourth check that checks that the that they have some values when they are inbounds at 4, 4. Should be some and none. Get value here should still be none because it's giving us the inner data safely. And then you should be some at mute none. Perfect. Harmony dot set value lock to 4 to 5 to black. And then we assert that 2, 5 is black. 2, 5 is black. Wonderful. All of our getter and setter abstraction seems to work. Hurrah! Time to write interactions. Shall we start with place? Let's start with place. It's the simpler of them. So, step 1, we destructure ourselves. Act place at location color. Might be in the order color location. It's in the order color location. That probably shouldn't matter, but I'm gonna keep it consistent. Is self. Right, we now have our color and our location to work with. So harmony dot get value at location dot get value at location. If let some if harmony dot get value at location dot is some, aka there is a value of any kind there, whether it is if there exists a value of any kind, return an error. In fact, let's think about what we need for this, rather than just throwing errors willy-nilly. And at the end we can check there's a path to every error, and that will give us a good overview that we've mapped it all. So what we need to do is just put a stone down. So if okay, well no. So let target and mute option stone. So we'll assign ourselves a target, and then that should give us a lot of failability information. No, you know what? No, screw this. Manual checking for explicitness. So first thing we check for is placement outside bounds. So we say if we'll say let target be equal to harmony.getNew location. We say if target is none, return at place act place at error placement outside bounds color location. Return that error. Okay. Next up, if harmony.activePlayer is not equal to color, return error act place at error placement out of turn color. Okay. And you know what? This is a cheaper check, so we do it first. Okay. So at this point we've established that we have not got a out of turn placement or a out of bounds placement. So then we need to check that we are not placing on a stone that already exists. So what we will say is if let some target equal this, else that okay. So we're saying now our target here is a mutable reference to an optional stone. So here we can say if target is some, return an error, place error, placement on stone of location. No, okay. If let some existing stone equal target. Okay, this is better done as a match statement on harmony.getNew location. Because now we can say some mute some existing stone. So if there is an existing stone, then we return a act place at error placement on stone, and that stone needs a location and an existing stone. Right, then our next case is where we have a target that is not this. Which is ideal. We have the case of none, where we return that our placement is outside of bounds. We have the replacement of some target, where we say target is some color. Okay. Right, that's all the code for playset. We check that we've got, we're in color. Then we say if we've got an existing stone, we return a placement error at the location for the color of the existing stone. If we have no, and so in fact we should do this first because it's a more lax check. If we have, it should reorder them internally, but for my own reading. If we have nothing, return placement error. If we have an existing stone, return a, hey, we've got a stone here error. Otherwise, say, hey, yep, we're good. Right, that looks good to me. Okay, so let's go test it. Tests. Test. Act place at. Let new harmony equal harmony new 9x9. Okay. Harmony.commit act.place white.at 43. Assert ec harmony dot get value lock 43 some white value. That should occur without error, so we can just unwrap because panics are equal to failures. Okay. It failed. Placement out of turn, of course, because we start with black's turn. Act place at. Okay, now one thing that's important to know is that after we commit an action, if that action is successful, aka which we have control over in the commit method, we should change whose turn it is. Always. The active player should just be public information. The player whose turn it is. Right. So in commit, after we apply the action, gives us a result. We map that. We don't care about what the value is because it's a non-existing value. And then we say self.activePlayer not equals self.activePlayer. So that way, if our action is successful, equals not self-directed player. And then that should still be, because it's a statement, an equals expression is a statement, that whole thing evaluates to a unit, which is what we expect the type to be here, so we can do that map operation for free. Okay, and then we can test that over here in... And that's why we've written this code like we have, so that writing an extension like that became trivial. And hopefully developing this should keep things trivial for what is going to get somewhat complicated at times. Now, one thing I don't like is that my tests function here is relying on panic functionality. So instead what I'm going to say is for it to use a question mark in there. Doesn't like dying. Is it impla? Type annotation needed. Error doesn't have any internal types, right? No. Okay, you know what? Not gonna bother. Just gonna unwrap. And the next one we do is white. In fact, white. Unwrap. Cool. That worked. So we successfully go from black's turn to white's turn. Okay, next up, action move. The more complicated of them, because it has to check more. But that's fine, because it should just be a case of going through, eliminating each error. Like we did before, until it is all good. So, step one. Let act from 2 equals self, destructure self, to remind ourselves that it no longer exists. Okay. And then we can say match harmony.getMu from harmony.getMu 2. Okay, so we have our from 2. Okay, so first check we need to make. No stone exists. No stone exists at the location being selected, or it is out of bounds. For which get value is a nicer call. This is why we've built get value. So we can say none, anything. This returns an error of act from to error. No stone exists at from. Right. Nice simple case handled. Next up we have to handle that we do not, the case where we do not own the from stone. Some color, if color not equal to harmony.activePlayer. To error. From stone not owned. Location. And which color does it want? I assume the color of the stone. Color. Owned by color. Okay. What don't you like? Interesting, that's only a warning. Cannot borrow that as immutable, also borrows mutable. This has been now. Okay. Interesting. Let active player equal harmony.activePlayer. It's copyable, so I just need to acquire it earlier, and then there's no more warning. Okay, cool. So, from stone not owned. Okay, target not orthogonal. Is a check we do on from and to, where we say if from.x is not equal to 2.x or from.y is not equal to 2.y, aka if they do not share one of those two axes, then we return an error of act error not orthogonal from 2. Okay. And then finally, our path blocked by. This is a bit more complicated because this requires us checking everything in the line, basically. How do we want to structure this? Well, well, first of all, so this is only legal if the above cases haven't occurred. Which is to say that we've got some color here that does not meet the previous clause, and some and mute target location. You know what? We should do get mute here, and then this here is none or none none. Which means I might just delete the get value API. Hello? What is the problem with this? It should be legal. Oh, right, of course, some and mute none. Cool. Some mute stone color. So if we learn that we are inbound and there exists a stone of color, and color is not equal to the active player, otherwise some mute some color, aka our origin and our target, and these we have to do a you know what, we can do the orthogonality check up here. We can say if while from dot x to from dot y dot wait, from dot x dot dot 2 dot x, so 4x in that. Now we want this to repeat itself. There is a way to do that, but I don't know if it's in itertools or iterator. It's like the repeat method. Chain, map, filter, enumerate, take while, skip, take, flatten, fuse, inspect. Or any it is cycle. Dot cycle. Gotta put premts around this. So from x to x cycle, zip that with from y to y. Oh, what happens if these are backward? I kind of hope that Rust just kind of does the same thing, but I don't know if it does. Let's find out real quick. For x in 8.4 print line x. Do you panic? No, you do nothing. Right. Let low x equal from dot x dot min dot 2 dot x. Let high Is there a min-max? I'm assuming there is. Comp min-max? No, there's comp max and comp min. But not comp min-max. Interesting. Okay. We can use pure cheese by calling the slices in place sort operation. Right. Now I'm okay with an unstable sort, right? Yeah, we use sort unstable. Okay. We're gonna use some cheese. Low X, high X. From.x to.x dot sort unstable. Low y, high y equal from.y to.y. Sort unstable. Okay, in theory, this should be as quick because it's just an operation swap. This should be as quick as it can possibly be. Wait, sort unstable is not is a I need an out of place operation. I'm now questioning whether or not this is actually quicker. Let x's equal from.x to.x. Yeah, okay, no. It's going to be quicker for me to just do a quick reordering, which is to say, you know what? Wait, let's we can optimize later. Micro optimization can happen later. Let low x equal from.x.min.to.x. High x max low y high y okay. And then here we can use low x, high x, low y, high y. Okay, now the other really important thing is we actually want one higher than the low x and one lower than this, but only if they are not already the same for obvious reasons. Because here we want it to yield over and over and over again. So am I better just detecting directionality? Maybe. Wait, no, it's fine. If n right, so we create this structure here. We then map over the X and Y location. We say lock XY. Okay. Right. So with our, in fact, chaining is a free operation, so let's use it to keep this sane. There we go. So we create a location from each XY. This should also be cycling. Okay. And then the goal is to count the number of things we hit, because we should hit exactly one, aka the starting location. And if we hit anything else, that's a problem. And we can yield the error. We can yield the location. Okay. So here, actually, what we want to do is we want to filter map this down. Yeah. Okay. So then, what we say is we can say, because remember we are expecting exactly one of these. Whether it's the start or the end. No, there's no way to do that. Yeah, okay. We're best off actually doing a detecting directionality. So what we're going to say is if from.x is to.x, wait, we'll say vertical equal from.x equals to.x, or rather horizontal. And then if we are not horizontal and we are not vertical, which means after this we know that if horizontal is false, we are definitely vertical. Because our x's aren't the same, therefore our y's must be the same. Okay, so if horizontal was what I was doing before clever? What I was doing before might have been clever. What I was doing before was clever. I just hadn't realised it was. Okay, filter map this. So we're going to map this so that each location is harmony.getValue location, which means it's none if it's out of range, but we don't care about out of range, and it's because that'll get handled later. But more importantly is it's location. I have no, I don't. Location. Okay. So I'm gonna format this real quickly. Sure. Right, it needs a second statement in here for it to care. about how to format this. That's a placeholder. There we go. Now I have proper formatting. That doesn't like question mark? I just doesn't like the return type. Okay. Right. Okay. Map the color to an act from to error of path is blocked by color and location. Okay. And then we filter the whole thing by location is not equal to from. Oh, I know it's the path block by variant. Okay. How do I want to do this? Because the ideal is to do another filter afterward. But afterward I've discarded the location data. No, I haven't. I'd start doing it sane. Location color. Filter map. Location. Something you don't care about. Filter where the location is, so only show me where the location is not equal to from. Location is a location. Expected enum. Just filter that. Okay. Location is copy safe, so just deref it. In fact, dereference it like that. Dereference it like that. It's cleaner. Okay, and then after that filter, we map it to be, so anything left in here is a location that isn't our from location that has been found on the path from the start location to the end. Location color to act from to error blocked. Location color. Okay. And then after that map, for error in this, turn error. Right? If there is any errors in this at all. And so for optimization's sake, we'll tell it to only take one. Boom. So that should work. We say for the course of our X and the course of our Y, repeating values if we... Oh, they both cycle, so they'll both cycle forever. Shit. Okay, it's itertools has a zip method, which is the zip method I want here. It's called zip longest. Create an iterator which iterates over both this and the specified iterator simultaneously, yielding pairs of two optional elements. When both iterators return none, all further instances are of next will be none. Element is of type left, right, or both. Not quite what I want, actually. Oh, such a clever solution if it weren't for me being an idiot. What happens if you zip two things and they're not of they're of differing lengths normally? Zip. Zip plus two iterators. Zip returns the iterator. If either iterator returns none, next one zip for return none. Okay. Because I want to cycle shortest. Yeah, okay, I do have to do direction detection. No, I don't. No, I don't. What am I doing? Hey, brain. Cycle, take... let max len equal from... Let max len equal high y minus low y dot max high x minus low x. Take max len from the cycle. Take max len from the cycle. Now it won't go forever. Because it can only go until it's taken as many as there are. Right, that's that fixed. Test time. Harmony is a new Harmony game. Okay. I mean, get place out, we should check every error as well for full coverage. Assert ec that harmony dot place black at lock 00 dot is air. Assert that because we know that white is the active player, harmony dot place white dot at lock 43 is error. Harmony commit act dot place like that. White is the correct color, but placing it at 4-3 should give an error. Outside bounds. Okay, just need to check outside bounds then for the tests. What are you complaining about? Oh, I haven't actually written the "you were successful" case where we say target equals some color. I think this might be one of the legitimate uses of the @ sigil in a match statement. Search for pattern syntax. @ bindings. The @ operator lets us create a variable that holds a value at the same time we're testing that value to see whether it matches the pattern. Okay. So the goal is to check that source at some color. Maybe that works. Target cannot okay. Some source. Sorry, we can reword this. Okay. Source is none. Right, that should do it. We say our target gets to be equal to some stone that should be at our source. Oh, if source dot is some. Some for any target not covered. There needs to be a new error type that we've just discovered because of Rust's exhaustive pattern matching. I mean, in response to chat, use std comp min max. They're just traits, like they're trait methods, so I can do min 1.x, 2.x if you prefer. Like these are the same expressions. I just had to import the methods, whereas I know min and max are automatically in. Okay. But yeah, no, so Rust requiring exhaustive patterns informed us very politely in an error. That we don't handle the pattern where we have sum and mute sum, aka not this here, because we handle that down here by handling where we have some source, some target. But what if there was no target? And so this here is, which will only ever happen. It's only ever meaningful to us that there is no target because this is a get when target is out of range or when target is out of bounds. And so I need a target out of bounds error. The target location lies outside the boundary of the Harmony board. Target out of bounds. The location which is out of bounds. Then down here we say act from to error, target out of bounds, location. The target location is out of bounds. Location. Okay, and then down here, I get to say if for any reason we have a none there, our target's out of bounds. And with that, that should be every possible case handled. Interesting. It doesn't think that's every case handled. It doesn't believe we're handling some and mute some. You mean this case that we are handling? It does mean that case that we are handling. I'm just like convincing it that we're handling it. Hello? Some and mute some underscore some underscore. Oh, it's like, hey, what if not this? Okay, we're gonna do this if source.map unwrap or false. So if there is no stone, wait, yeah, we handled that there. Some and mute none. Just gonna bring all those back to underscores because I like them better reading that way. Okay. So what it's complaining at is it wants us to better handle the situation. What are you erroring at? By move into a guard pattern. Sources and mute, right? Get mute returns, yeah. Right, I see. Because you yield an unmute option, and it's moving the unmute option. And it's mostly just complaining at us because of the case we don't cover, which is if well, let's see how stable bind by move into pattern guards is, because I feel like it should be pretty stable. Bind by move into pattern guards, tracking issue. Ah, okay. It's done. It just needs documentation. I have no problem using a mostly undocumented language feature if it makes the code nicer, which in this circumstance it most definitely does. That should decrease my errors. Because I'm moving. Yep. It's two mutable references into it at the same time. So I need to be able to tell it that these are disjoint. that these two are, because from and to are different. Here we go, fighting the borrow checker. Okay, you know what? If I just don't move... Oh, but I need to move because I need to do this bit here. Yeah. Okay, bub. We're gonna change our style a bit. We're gonna say... Right. Yeah, that's a real problem. That legal? Feels not legal. Might be legal. Non-linear lifetimes might save that. Not non-lexical lifetimes. Got it. First borrow occurs there. First mutable borrow occurs here. Okie dokie, I have to convince it that these are disjoint. How am I going to convince it that these are disjoint? Which is to say that I am not going to be modifying the same place at the same time. Well. Yeah, I do have a specification for Harmony lying around. I pulled it up on stream earlier. It's, in one of my 17 open web browsers. Yeah. I think it's hosted on harmony.llbluemire. llbluemire.github.io/harmony. Oh, nah, that's broke. Did I delete it when I was doing my big cleanup of all of my things? Should be in there. Alright, GitHub page is being weird. There we go. There's the Harmony specification. It's not complete. I think there might be some quirks that are like... I don't know. Harmony's not been a studied game, so I don't know if there are quirks that make that invalid, but that's the spec as it stands. So here's the thing. It's shouting at me because I have a mutable borrow of Harmony here and a mutable borrow here. I need to find a way to solve that. The best way I have to solve that is to break up some of these checks. So if harmony.getMut2 is none, oh well, because the thing is, right, Okay, so from a type perspective, all I need to guarantee is that from is not equal to 2. And if, which to be honest is another error. So, hey, Rust just helped us find another error. The error where they're the same. Target is source. From is 2. Both the destination and origin of this action are the same, thus it is a no op. The location of both the destination and origin. Okay, cool. Right, so here we get to do some fun things. So first of all, it's the cheapest check. If from is 2, return an error, act from to error, from is 2. Location from. Doesn't matter which one I use, they're the same. Right, next up, check they're not orthogonal. Next up, throw out the path blocked by error. Right, next up, we know from is not 2. As from is not 2, these are guaranteed to be getting disjoint things. Therefore, right, manual check. Multiple mutable references to data, to internal data structure of Harmony is only possible, are only possible in the event where their index is the same. This will only occur if from and to are the same. This function manually rejects from and to earlier in the event they are not the same. Therefore, this, if they are, manually returns an error earlier if they are the same, and thus the following code is safe. Okay. Right. So the structures we're looking for are option. So I'll say I'll call them from and to, and then I'm going to type annotate it for myself as being option mu option, option mu option. Okay, and then we say stone, okay. And now our unsafe operation to actually get these is to say harmony.getMu from dot map n as star const n star const option stone as a star mute as and mute option stone. That discards the lifetime information on it, in theory, assuming I know what I'm doing. Big assumption. And then we want to do the same on 2 to discard the lifetime information on 2. Right? Transmute. Yeah. Turning a star mute into a mute. Yeah, okay, cool. So then I need to call use standard mem transmute. Transmute. We're transmuting an option stone into a that's our transmutation. Right, that and that, but this is for 2. Is this wrong? Hello, error message, you gonna show up? Or is... Okay, VS Code is doing the weird thing. Hi. Now I get to call these from 2 for the purpose of everything that should be happening. Those are the same, but with extended lifetimes. No, this is bad. This is because I'm tired. Why am I doing this? I'm writing bad code because I'm tired. Yeah, okay, no. Scrap this. Scrap this lifetime extending. Write less optimal code. Brain. Like, even this is janky as all hell. Right, so. What have we handled? We've handled from is 2. We've handled target not orthogonal. And we've handled path blocked by. Checklist. Need to handle target out of bounds. If harmony.get to, so they're called just from and to, yeah. If harmony.get to is none, return error target out of bounds. Okay. That's that done reasonably. Okay. So, we know if our target is out of bounds now. Next up, no stone exists. If harmony.getFrom is none, and then and onto itself is none, kind of want to type check that. What type are you? You are... wait, no, we have a better thing for this, because this here is just get value. Is none. No stone exists. No stone exists at that location, or it is out of bounds. Right, no stone exists. Handled. From stone not owned. Next on the agenda. Right. So here, that's actually 2 birds, 1 stone, because we can match on this. And if it is none, we can do this. If it is a color, if color is not equal to harmony.activePlayer, then we can return an error of act_from to error. Not owned. Color and location is from. And then lastly, in any other situation, do nothing on that check. Right? Some color. Right. This here is the hey, don't do anything. From stone not owned. Just needs owned by, which is color. And then down here, unimplemented. Cool. I will be back in a minute. I am back. Right. So, we have handled From Stone Not Owned, we've handled Not Orthogonal, we've handled Path Blocked By. We've handled From Is 2. I think we've handled every possible error. Let's count them real quick. There should be 1, 2, 3, 4, 5, 6 kinds of errors we can get back from this. We are returning 1, 2, 3, 4, 5, 6. Okay, cool. Which means we should then, with all of the possible error cases handled, be good to just yeet ourselves out. And we're not handling From Is 2 here. Act from to error. From Is 2. 2. Sorry, it should be just location, because they're the same. Both the origin and the destination are location. Okay, that's that handled. They are right, these parentheses are unneeded. Now, cool. Okay, so what we do down here is we return OK after we say okay, source is equal to harmony.get from. Unwrap that. Option. So step 1 is we set the destination, which is actually we do color, stone to move, which is a stone, is equal to harmony.getValue from unwrap. And we know, right, which means that that is actually to we can do a bit of compacting, so you can compact that into here, because that is the sum color case where the if guard doesn't meet. So we can say stone to move. And then at this point we can set our target location, which is harmony.setValue to stone to move. Okay. And then after that, harmony.unsetValue from. Right. This should throw errors and a half, if I'm being honest. Oh, because I'm only getting as immutable here, which means I'm free to get mutable down here, because I'm elevating, and because I've got access to non-lexical lifetimes. Yeah. Okay, cool. That's that function done. Didn't have to do any unsafe lifetime lengthening, just did a bunch of stuff. Right, so if harmony get 2 is none. Right, so what I might... Let's see if it breaks if I say harmony get 2 here. All of these are agnostic to what that value is. Except for this one, which considers it the target. Does this now fail? That's the question we have to ask. Is this invalid code? This is where I expect it to break. That's fine, I can elevate Harmony active player. Okay, lowering that check didn't break anything. Okay, cool. So the key here was using get value in combination with unset value so that I could take advantage of NLL. Rather than using get mute. So I use get mute here, it would all break down. Because of the duplicating. Whereas here I'm free to unset the value because we know that target has already been although we hold this, we can verify its disjoint, I suppose. To some extent, or I wonder. Be interested to know why that works. There's probably a good reason. I'm probably just too tired to process it. Okay. Can I lift from is 2 into the checks down here? Is it even smart to? No, it's a quick check. It should happen at the start. Okay. So there's a little bit of work duplication going on here. Because get value and set value both compute the location. But that's negligible. Okay, time to test act from 2. So action move. Right, so we let our harmony ball be a 9x9. I'm gonna say commit act place harmony dot active player at lock 43 at lock 00 as is a traditional opening, or 00. I'm just gonna have this play out a traditional opening, which is one player takes 00. Another player takes 0-8. The opponent takes 8-8. They take 0-8. Take 8-0. Okay. Then let's say so player has got. They might go for the middle piece 0-4. We'll probably see an opposed player 8-4. Okay, so here is the thing. Movement is only legal under another circumstance, which is that it has to. Movement is only legal if you lie on a harmony. Or is cage? You can move out of the cage. Movement is only legal if you are in harmony, if you are in a harmony or if you are in a cage in that direction, which is a 0-width harmony. And 0-width harmonies are ignored for the purposes of harmony tracking. Yeah. Okay, yeah. So I'm going to need to build the harmony model for this to actually be valid. Because you shouldn't be able to move unless you lie on, unless your stone is in a cage. A legal cage, I will say. So I need a method get zero width harmonies and a method get... okay, I need a method get all harmonies and a method get all uncaged harmonies or all non-swoosh harmonies. Because basically, well, they're in the advanced bit. These guys here, zero width harmony groups or cages, are messy, to say the least. Essentially, what you do is you remove all other all other things from a group, which means I need to do group detection. Check if the stone is dead with them not there. So essentially evaluate the board step 1 forward and see if that, not if any death occurred, but if that stone in particular died. And if it did, you remove the entire group and then you do a step forward. So I need to code harmonies before I can finish movement. I should have thought of that sooner. Okay, so on a more interesting, so act move, I'm gonna just in here say to do this is incomplete. It should eliminate, it should deny movement that is not along a harmonic line. A harmonic line, I don't know if we explain them in here. Here, yeah. A harmonic line is extended out until another stone is hit from stones that are in harmony. So these two have a harmonic line that extends the entire board, and these two have a slightly shorter one because it doesn't extend all the way out to here. You can move a stone along its harmonic line, which is functionally just if a stone lies on a harmony, you can move it parallel to that harmony, provided you do not get blocked by another stone. Is the detection algorithm I'm using, rather than generating harmonic rather than generating harmonic lines and checking that something lies on a harmonic line, because technically you can't move this to here because it gets blocked by this. So harmonic lines are the philosophical way of looking at it, but yeah. Stone placed around the border of stone can be moved along one of its harmonic lines as many spaces as 5, provided a straight line going over the edge of the border passing over another stone. Next, said stones are removed. Their own coloured stones are removed first. If the player moved a stone, their enemy stones are removed first. While removal is happening, stones of the colour being removed are inspected. If they are on enemy harmony, they are dead and are removed. Next, the opposite colours are checked and dead stones are removed. If any stones are removed, the step is repeated to allow for chain reactions. When all the chain reactions have been resolved, it becomes the next player's turn. Yep. Okay. So we need to do harmony generation. We've made it to the namesake of the game. Actually detecting if harmonies are going on. Yikes. Right. In here, get a list of all harmonies. So we're going to have fn gen harmonies uneliminated harmonies. Get a list of all harmonies without elimination. Internal use only. Which means it doesn't need a dot comment, but I'm giving it one anyway. Right. And it means it's also time for a new file, harmony.rs. A harmony. Harmonies are the connections between stones. Has got a low magnitude, a high magnitude, a direction, which I will call a horizontal boolean, which tells you whether it's horizontal or vertical. A low, high, horizontal, a color. Represents a single harmony. Okay. Okay, represents a single harmony. Color. Should I do start end rather than low and high? And then I can detect horizontal, low magnitude, and high magnitude. Yeah, I'll do that. With a start location and an end location, and then they have a color that is shared. So I can do clever things like the cycle loop I did before. Okay. Get uneliminated harmonies. So, how to find all harmonies? You do a vertical pass and then a horizontal pass, or a horizontal pass and then a vertical pass. Whichever works for you. Right. Get uneliminated harmonies. Returns a vector of harmony. I could make it an iterator, because it is one, and so I'm going to. Okay. Right, so we have to go from 0 to self.sizex. We will do our x pass first. So for each x coordinate, for each x coordinate, for each y coordinate, okay. Flat map, I suppose. That there should be a map of yeah. Yep. Okay, so in here I need to generate my harmonies. So this is for x against y. I will also need to do a pass of y against x, which I know sounds like work duplication, because it is. But, No, I can do them each in the same pass. Okay, so what we have is we have so for every y, each y might be the start of a harmony. For which we say let low y equal yeah, so we do 0.self dot we do self dot size y plus 1 to self dot no, we do y plus 1 to self dot size y, and then here we do y minus 1. Okay, well, this here means that we need to add a new invariant over here. Yeah, we can't have a 0 by 0 board. For now, I'm going to panic. I will introduce harmony constructor error later. Should I do that now? No, I'll do that later. It's a lot of implementation details because I've got to do formatting and such. The reason I don't want panics is because panics across thread boundaries equals undefined behavior. You know what, for now... No, it breaks loads of code. I'm not going to bother. For now, I'll panic. Right. So, from here to here. Filter. Okay, you know what? Yo, hold up. We want every X, but we only give a damn about certain Ys. We only give a damn about Ys where harmon self.get value xy is sum. Get value at location xy is sum. Okay. Now here's the thing. Again, here we only care Okay, so we now have y1 and y2 in a flat map. Right, so here, these, we have found them, but we only care about them if they are the same color. Add a new filter to y2. In fact, filter map. Oh no, because we don't want to lose the coordinates because stones don't have an intrinsic coordinate to them. Self.getValue lock xy1 value lock xy2. Okay, filter where they are the same stone. And in this event, where they are the same stone, and they are both stones, cool Q technology in chat, this is in fact Rust, you see. We're going to say that we return a harmony. From is location xy1. 2 is location xy2. Color is self.getValue lock xy1. Ah. See, what I've done is done something really stupid. Board. 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 Have I used capital harmony anywhere else? No, good. Just in all of my tests. Replace capital harmony with capital board. Replace lowercase harmony with lowercase board. Oh. Should probably have been case sensitive. Harmony with harmony in a case sensitive sort of with board in a case sensitive sort of way, and then lowercase harmony with lowercase board in a case sensitive kind of way. Yeah. Okay. Oh, but of course acting expects a harmony when it should expect a board now. And this should be called board, let's be real. And then in here, capital harmony is actually capital board. And lowercase harmony is actually lowercase board in this instance, this instance, this instance. Cool. And then how about you? You are now board, you are now board, you're now called board, you're now called board, you're now called board, and you're now called board, but none of you are. And then you're called board. Just have a quick look at all the other lowercase harmonies. Wonderful. There's all my errors chased down, probably, right? Now you are true harmony because you have got pub mod harmony and then harmony coming in. Okay. Start end color. I hate this code. I need to clean this code. This code is going to make me sad the longer I look at it. Right, let's make this code not sad. Okay, what is your lifetime problem? I'll accept that you have one because this code is horrible, but... Okay. Like, you're not like... Okay, in theory, and this is just a theory, it's this. This is what you want. I'm gonna make all these move closures because I don't care about the internal values used. No, okay, you know what? I'm not gonna do that. That's causing more big gore. Right, gonna look at underlying problem and fix underlying problem. Underlying problem is that force the closure to take ownership of self. See, no, maybe. No, I'll need it later. Okay, here's what we're going to do. I'm going to rewrite this. 0 to self.size x. Flat mapping x. 0 to self.size y minus 1. Filtering. Filter mapping. Okay, so xy, this is what we have before, but instead of its sum, we're going to map that to have its color, but also its x and y. Color going to color x and y. And then we get to map color x and y. Even no, x still exists though. Next x, we get to map color and y because we have learned what color is. And we get to map them from y plus 1 to self.size y. And then here, I'm going to call this y1. And we map this color to y2. And then here we say, yo, this is a harmony. It's got a start of xy1. It's got an end of xy2. Yo, we want to call one more filter, which is that just run that quick filter, then we map. Color is color. Okay, but we make this a flat map instead of a map because it needs to be flat. And we make this a flat map instead of a map because it needs to be flat. Well, this one doesn't need to be flat, this one needs to be map. Ah, hello, 2 errors. Expected function. In this entire mess. Alright, of course, we're going to remove this garbage. And that might fix some of the errors. Perfect. Color 2, dereference. You're free. Don't dereference you there, dereference you over there. You're a free value. And that, I mean, dereference you here. You're a free value. Wonderful. Movement errors. Okay, this is annoying me. I don't need you anymore. Next up, librs. May outlive the borrowed color. I suppose you might. Next up, I suppose this might. I see it wants both of these to be moved as well. And it supposes that this should be moved, and therefore that this should be moved. Ah, wonderful. It worked. Generate unlimited harmonies. Now I have a question. Can you infer that lifetime restriction now? Because I hate writing lifetimes. No? No. Okay, that's fine. Right. The lower value location of the harmony, the higher value location of the harmony, the color of the harmony. Okay, so that's that done. Yes, well, derive, debug, copy, clone, ec, partial ec, debug. Could probably slap a hash on that, but not going to bother. Huzzah! Right, wonderful. So, we are now able to get a list of all of the harmonies. We're going to test this in a test. Uneliminated harmonies. Okay. We're going to use an example right from the book. Straight from the horse's mouth, as it were. So, here's the horse's mouth. And, here's an example we're going to use. There is... Is this still considered endgame? There's no shove. This is not legal. I mean, you'd want them to block there and give themselves that, and then... But, like, then they're just running stones. Yeah, no, that's endgame. By the way, this is the rule, if anyone's not seen Harmony before, this is the rule that makes Harmony good. That stone doesn't die. Okay, so... 1, 2, 3, 4... 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Wonderful. Let me board equal board new 1, 2, 3, 4, 5, 6, 7. This is 7 by 7. 1, 2, 3, 4, 5, 6, 7. It's a 7 by 7. Okay, on with this 7 by 7. Place me a black stone at 0, 0. Okay, so 0, 0. 6, 6. Response. 0, 6. Response. 6, 0. Response. Black plays a nice middle stone at 0 in X, and of course black, white, black, white. You know what? Harmony dot board dot active player. That way I don't have to care about alternating these because it will automatically alternate them for me. Okay. 1, 0, 1, 2, 3, 3. With the response at 6, 3. Plays an expansion at 3, 0. Now when I said plays a response at 6, 3, I of course mean, yeah, 6, 3 there. Plays an attack at 3, 0. Plays a response at 3, at 4, 0. Next up, we have a piece at you know what? Let me just list all those coordinates. And then I can sort them into 2 different things, and then I can just generate it. Rather than trying to figure them all out by hand and figure out what order they went in, I can just put them down in a very neutralish order. Okay, so grabbing a screenshot of this area. Hopefully that didn't break horribly on stream. Okay. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Right, well, this one is just going to come down to upping the font size, I think. Wonderful. Okay. Stones for black. 0, 0. 3, 0. 0, 3. 3, 3. 0, 5. 0, 6. 3, 6. 4, 6. Okay, and then stones for white are 4, 0. 6, 0. 4, 3. 6, 3. 4, 5. 5, 5. 5, 6. And 6, 6. Okay. Zero, 0. 4, 0. 3, 0. 6, 0. 0, 3. 4, 3. 3, 3. 6, 3. 0, 5. 4, 5. 0, 6. 5, 5. 3, 6. 5, 6. 4, 6. 6, 6. Okay, this here is a placement game. It places down all of the places. Right. Now we need to figure out exactly how many harmonies are we expecting from this. So, to count them, I am expecting... We'll use red for this, so 1, 2... Wait, we'll do verticals first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm expecting 14 black harmonies. 4.get uneliminated harmonies .filter n.color is black how do you get the length of a iterator? Count. Assert equal this and what did I reckon? 14? Hold on. Count these red lines real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 is what I'm expecting. $14 black harmonies, hopefully. Okay, it got 9. 9. Well, I guess I have to look at what they are to see what it missed and see if I can find the pattern in what it missed. Okay. collect into a vector of the underlying type. Okay, so now I have a list of harmonies. I can look at them and figure out which harmonies it found. So, gonna do this on my other screen. Harmonies it found. It found a harmony going from 0, 0 to 0, 3. Good. For black. It found a harmony from 0, 0 to 0, 5 for black. Good. And it found 0, 0 to 0, 6 for black. Good. It then found 0, 3. Oh, I've only implemented vertical harmonies. Duh. That's why it's not found any horizontal ones. Because I need to come back here. And after it gets all the vertical harmonies, I need to tell it to get all the horizontal ones. Chain. Grab this. But instead of it going from 0 to self.x, it goes to self.y. This is x minus 1. You are y, you are x. We keep x. You are x1. We go x1 to x. You are x. We keep x. You are x2. We get y, and then we get x1 and x2. Okay, I'll go format you. Didn't close everything properly. Close the chain. No? That closes the flat map, that closes the chain. Right? Okay, get that formatted. And get that tested. 14 black harmonies. Come on. 14 black harmonies. 14 black harmonies that found them all. Nice. Okay, and then how many white harmonies are we expecting? Bringing it back over to the image. We are expecting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 white harmonies. Mm. 11. White harmonies. Exactly what I said there should be. And that is why we let code count harmonies instead of people count harmonies, because harmonies are a pain in the ass to see. Like, they're really difficult to see. Right. Next up, harmony elimination. Because you will notice this is the uneliminated harmonies. Which means I also need a means of generating the eliminated harmonies. which we will be doing allocation for because we need to store the old list. So we will say gen eliminated harmonies because there is no way to no standard board by size. Me and Sasha like 13 by 13. There is no standard board size because we never figured out what board size the game was good on. On a really small board like that, it's actually not that good. The game is like built for larger board sizes, like Go, because the larger you go, the more room for complexity you have and the more room to do things you have. But neither of us are good enough to play 19 by 19, so we played a lot of 13 by 13, and that was pretty fun. Generates the list of canonical harmonies, excluding now. There's another debate we have, which was it doesn't matter. We resolved it with it doesn't make a difference. Yeah. Now, here's the thing about getting a list of eliminated... So the original design was such that you want to find the harmonies that are, not on the board. You want to get the list of... Because the rule, in short, is if a stone lies on an enemy harmony, it's removed. Because of the cage rule, or the Zwidge group rule, that's not the case anymore. It still is, but we care about doing these group elimination checks where we find groups and we remove all of the elements. So I will need to do a get groups, and I might want to do that sooner rather than later. Because that's the important thing is the actual harmonic lines, like this here, you would actually expect there to be a no harmonic line across. The reason we draw one in is because it is what eliminates these. You would expect it to be eliminated by this bottom case here of dissonance, where this inner group basically tells this outer group to go away. But it doesn't happen because of the cage rule. So I mean, I guess as long as removals propagate correctly, I'll do group detection next. Group detection is the next most important thing. Generates all of the groups all of the multi-stone groups on the board where a group generate all of the Zwidge groups. Pub fn get Zwir groups. Okay, get Zwir groups. Now a group is a vector of locations. Now I need to think of a group finding algorithm. Now the obvious one is you create a list of every location filter that for every location where there is a stone. Then check if adjacent ones are present, and if any adjacent are present, you add them to the appropriate partition group. Okay, yeah, that's doable. So Zoology groups give us a vector of locations, where each outer vector is a group, and each inner vector is a set of locations. Right. Let all locations equal 0 dot self take sim and self dot size x 0 dot self dot size y dot map block xy. Okay. Dot collect. Okay, so step 1, we get every location, all of them. Vector of location. I know this is correct. It disagrees. It's because I haven't actually written either of these correctly. Okay. Right. But we want to filter it where self.get value at lock is sum. And then we actually want to do a partition on this so that we can split it into the blacks and the whites. Dot collect. Okay, so this gives us all locations. I'm gonna partition that. There is a way to do that. I think it's literally called like partition. Might be an editor tool. Kinda hope it's not. Partition. Consumes the iterator, creating 2 collections from it. Sure. So we've got black and white. partition kind of want to make these hash maps actually. I think I am going to do that. Filter map value dot lock dot map lock color lock color probably partition lock color is black. Okay. Get value map, filter map, partition. Oh yeah, so there should be a hash map, location stone, location stone. Hey, which gives location a reason to implement hash map, hash? Unless it's numeric, kind of. Can I btree map it without implementing hash? Or does btree map need a hash as well? Hash. I'll use the hash map. Use standard collections hash map, and then go implement hash for location. Okay. Because I'm going to put an ampersand there, and then that's okay. Right, cool. So now we have a map of blacks and whites. But we don't actually need to have a hash map. We can just have a vector because we know the color, because that's the point of the partition. We don't have a partition map. Really? No partition map method. Consumes the iterator, creating two collections from it. You're asking about derive hash? It means let me use it. I can remove that. It's a zero cost abstraction. It doesn't actually cost me anything to leave it in there. In fact, it should be in there because it's a derivable trait. That is like ideally it would auto-derive and I wouldn't worry about it, but there are times you don't want auto-deriving, and so I'm not too worried about it. If someone wants to, they can implement a deref chain and do like have their own extension that allows them to hash them. But yeah, it's the important thing with Rust. Does having things exist doesn't cost anything. See, it's the thing, I don't want it to collect. I want to like partition. Okay, itertools has a partition map, so I'm gonna just have to cave and use itertools. Alright, we gain our first dependency. Itertools. Use itertools. Itertools. Partition map. If this hold on. Partition map your values. Uses its either API, I see. Use itertools either. Either left lock. Else either right lock. And because it's a map, it doesn't take it by reference, it takes it in by value, so it can move out. Okay, cargo. So now we should have, yeah. So now we have a vector of all of the black locations and a vector of all of the white locations, and it is semi-nicely presented. To be honest, does it undo this or does it allow it to stand? Okay, I like that better. That's more readable to me. I'm going to swap lock for location, though, just to avoid confusion with the lock macro. And then build it. And it should build okay. Found... Okay. Alright, cool. So, we have ourselves an array of all the black locations, an array of all the white locations. Now we need to group these ridges together. which we can do with for for stone in black. We're gonna have to do this for white as well, so it's fine. So this is gonna be like a chain fold operation. I'll write it the lazy way for now. Let at mute ac equal vec new. Convert to fold. Okay. So for stone and black, now what we do is we need to check for every stone what's adjacent to it, and then for every stone adjacent to that, what's adjacent to that. So really what we need is we need a get adjacency boundary for locations, where we take in the origin location and then a I into iterator item location origin list I. Okay. Okay, so, and then that there returns a I kind of want to make it a hash set. It's technically a hash set, which means I need to allow hashing again. And bring in the hash set. Yeah, like technically these are hash sets as well, because they don't have duplication. All of this will get reordered later, so I don't need to care about the order for now. Bring hash back in over here. So the reason I'm switching to a hash set is because it preserves all of the same niceness while acknowledging that each element in this is going to be unique and unordered. Okay. So for each I in the list, let's set mute set equal hash set new set dot insert origin. Okay. For each element in the list, for E in set, so for each element in the set, and that's the set so far, because we're going to be mutating on the set in here, or rather we're going to be queuing to mutate on the set in here, because what we're going to say is we'll say let mute is adjacent equal false, and then if is adjacent set dot insert I, Okay, how do we determine adjacency? We say something is adjacent. If E dot... These are locations. Locations just have X and Y. Yo, type check me properly by unimplementing this. Thanks. Thank you very much. So, so if E dot X within 1 if one more than E dot X is I dot X, or if E dot X is, or if I dot E dot X is, yeah, is that, then it's got an X adjacency. Or if E dot Y, wait, then it's adjacent in X. It needs to be adjacent in X and Y. And I don't know the operator precedence between or and, so E dot Y plus 1 is I dot Y, or E dot Y is equal to I dot Y plus 1. Is adjacent is true. Okay, so that should get the adjacency boundary. Alright, but now what we do is we use it up here, and that way it stops shouting at us by saying for L in black, get adjacency boundary, let's see, black, okay, right, so now we can clean this up a bit. So what we can start by doing is saying list dot into iter fold. We're folding over a new hash set. Is there a hash set with single element? Okay, we can do like origin dot into hash set. Right? Slice has into hash set, right? No, only from an iterator. Okay, you know what? So what we do is we say we're going to fold, and we're folding the initializer, which is let new set equal hash set new set.insert origin set, and then the fold function, which takes in ACK and a reference to each element. But let's be real, in this case it's giving me each element because I'm using a moving iterator. Okay, cool. Then for each one of them we say if we say set, which should be called set.iter .any any item any, let me call this origin, any element it's not, this is because you're an iterator over the list, right? So you're not the origin, you're the foreign element, you are the source. And then in here we say source.x plus 1 is element.x, or source.x is element.x plus 1. And source.y plus 1 is element.y, or source.y is element.y plus 1. Right. Fold init b, where b is just an item. Interesting. Set if I called this hash set new, would work, right? Wouldn't complain as much. Interesting. Alright, you know, let's just put that semicolon there and then that'll stop complaining. Yep, cool, figured it out. And then I can go back to saying new set equal hash set new set insert origin set, and then set element for each element of the set. Okay, you're a boolean, so we say if you set.insert elements set. Okay. Right, this other problem that has just occurred to me. Actually, there's two problems. We don't want to go over sets. We don't want to just go through this once. We want to go through this until we don't get any more insertions. That is to say, we want to go through this because if we do an insertion, that's expanded our search, and means that any previous element might now be valid. So what we have to do is first of all make the code readable, and second of all acknowledge that given that after this insert we are essentially saying, hey, this set, we need to go over it again, that we should instead think of it for a slightly different philosophy, which is that oh, that's trivial. We have ownership, so we can have mutability. How do we solve this problem? Because it's fold over element in the list, but we might have to revisit elements in the list. I'm going to switch back to the procedural model. We can turn it back into a fold later. So if is adjacent is ever true, then we break out of our loop. We do an early break so that we're not going through everything. We insert it, and we say inserted is true. So we say let mute inserted is false, and we say inserted is true. Only if it's a new value, and this here says if the set did not have this value present, true is returned. So inserted is this here. If we get an insertion, so we say here, we say while inserted or rather, yeah. So long as we are doing insertion, we can do this, right? Let's just accept that list is also a hash set of locations rather than trying to make it generic. Now it doesn't move. We just have to dereference I here, which is fine because I is, again, locations, and locations are copy safe. Okay. So we set inserted to false. We early terminate. We only early terminate if inserted. Because if the set already has that, then we're retracing our steps. We don't need to break. If it's new, we need to reevaluate the whole set again. Right, cool. This here is the procedural version. What would the non-procedural version be? Annoying. That's what it would be. I might rewrite it later to be functional, but for now, no. Okay. Okay. So that gets the boundary for every stone. Are hash sets themselves hash? Can I compute a hash set of hash sets? My conclusion is that a hash set is not itself hashable. Okay. So we get back a boundary. No, you know what we want to do? We want to have boundaries. So we say let boundaries be a new vector. It's mutable. Each step of the way, we're going to filter this such that boundaries dot iter dot none, right? Dot. If it's in any, if it's not in any of them, then we care about it. If it's any, or rather, if it's in any of them, then we don't care about it. Contains. Let's be here. B is a slice. B dot contains n. Okay. That should type check now. Okay. So if it's not in our boundary, push it into the boundary. I expect this to break referencing. Hey. Cannot worry about is immutable because this board is immutable. This board is immutable here. Yep, that's entirely fair. Right, well. We remove the filter. We say if we say for boundaries if boundaries dot iter dot any boundary dot contains Blackstone. If any of the boundaries contain the Blackstone, then we continue. Else boundaries push this. That there is the right way to word that then. Right? Vec hash set location. Okay. black.iter.chain white.iter, and we just call this stone. So why am I even partitioning it then? Because here I check against black. Let's do this again for white stone. This is a ZCA because it's going to move them both, and therefore it doesn't cost me anything to add this extra for loop. It just saves me rewriting code. Color, stone, black, white, stone, stone. Right, should be fine. Yeah, it's fine. And color. Huzzah! This means that we now have the Zwiz groups, because that boundaries here is the Zwiz groups. That's our return type, yeah. So what I actually want to do is just make this a bit more nice by saying you know what, again, to make this code functional it would probably get a bit more optimized by the compiler, but for now we'll leave it as it is, because that gives us all those Zwiz groups in theory, because we haven't done any tests for it yet, so I guess it's time to do some tests for that. Test Zwiz group detection. Okay, so let's see how our Zwiz group detection is. See, okay, so going back to the horse's mouth, we're going to set up this board. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, which means we're going to set it up such that colors are inverted, because that way it's an actual legal board state without a capture having happened. Hey ho. Which means we are going to invoke the use of our old friend Microsoft Paint. And I'm expecting to get back that there are two... You know what? I might want to set up something a bit more custom so that I can detect, like, what if I put a black there and let that be a group? Yeah, you know what? That just solves the problem. 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep, sure. I'll just do that. I'm still going to use our good friend MS Paint to double check all the numbers, though. Okay, so 0, 1, 2, 3, 4, 5, 6. Across. 0, 1, 2, 3, 4, 5, 6 across the top. And we're going to artificially plonk a black stone here, just to add in one more Zwiz group. Get the old notebook up. Okay, black stones. We want to place these in such a way that the placement's illegal. No, yeah, because otherwise our test will break later down the line. So we will go 5, 5, 0, 5, 6, 0, 5, 4, 5, and then 4, 6, and then white stones we've got. You know what? We're going to simplify this a bit. We're going to take out this man so that there is no capture, and take out this man so that there is no capture. 1, 2, 3, 4, 5. 1, 2, 3. We're going to put a black stone here. And a black stone up here on its own. And that is going to be our test case. So black, we've got 2, 1, 4, 4, 4, 5, 4, 6, 5, 6. And then white, we've got 2, 4, 2, 5, 5, 2, 5, 3, and 5, 4. Right. Okay. Okay, and then we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. 2, 1, 2, 4, 4, 4. 2, 5, 4, 5. 5, 2, 4, 6. 5, 3, 5, 6, 5, 4. Okay, those should be the placements there. Right, and then what I'm just going to do is I'm just going to do board dot get groups. I'm just going to debug print that out. And then panic, just so I can have a look at what's in there. Because I want to see. Because I know what I kind of hope is in there. Oh, maybe... Okay. Sure. Okay, so the first thing it's found is the group let's make this look a bit more real. So black, black, and black. Okay, and then I can do lines to... Okay, so it's found 5, 6, and 4, 5. So that's 5, 6. Okay, 5, 6, and 4, 5 are in the same group, but they shouldn't be connected like that. Okay, then it's found 4, 4 on its own. Okay, we definitely have some selection errors going on. 4, 6 on its own. Okay, it's only found the diagonal, so I think that tells everyone what the error is. The error is in this. So here I'm saying, am I one up, one left or one right, and one right and one left? Obviously, this should be the extremely rare use of Zor. And I don't know what Zor is in Rust. I know what bit XOR is, but I don't want to do a bit XOR. I want to do a logical XOR. Control F XOR. Oh, there is no logical XOR. There's just bit XOR. Huh. Really? Alright, well let's try this, which is what I kind of expect it to be. I mean, I am half tempted to say OpZor, so that I don't have to do that, but... Okay. Okay, we're going to do a bitewise Zor because, and we're going to rely on the underlying implementation there because that should be valid. Bit Zor should be fine here. Right, let's have a look at... Okay, we've got some more realistic looking groups coming out. That's for damn Skippy. Right, 4-6. 4-4. 4-5. 5-6. It got that group. It got 2-1 out here on its own. It got 2-5. Okay. It went a bit mad here. Yeah, I suppose. Because it's 2-5 is connected to 5-4. Right, okay, so it correctly grouped these. Let's appreciate that, and it correctly got this thing out on its own. But it said 2-5, 5-4, 5-3, 5-2, and 2-4. Right, it thinks these are all a group, question mark. Right, that's what it's saying there. It's saying that given the highly technical setup I've got set up, that just to make it clearer what we're looking at here. Put a black stone here. And I put a black stone here. Right. So, what it's done is it said that 2-1 off on its own correctly separated. 5-6, 4-4, 4-5, and 4-6 correctly separated. But all the whites, it's just bunged in together. Right. Why? I'm guessing... That means that this has to be generating them all together. Right? Given the list of, given the list of whites, it's saying... Oh yeah, all the whites are, satisfy this adjacency property. Well, let's work it through. So, like, you don't... Like, they don't, though. We say if the boundaries, if any boundary contains the stone, we continue, because then the entire boundary should have been found. And then here we say get the adjacency boundary for the color. Right? And it's correctly broken up the black group. So why does it believe the white group? Like, just to pull up what we're looking at here. It thinks the white group is all one group, but the blacks it's successfully separated. I wonder, if it's real dumb, if I swap the order of white and black here, does it do white separation properly but not black separation? Or does it give us the same values? Okay, it's just done white first and it still has group. So it does genuinely believe... So it is getting an adjacency boundary for the whites and it is getting all of the whites. So that is something we need to figure out. So... Oh, no. It can't be that, because that is what's happening here. It's going... Right, what I need to detect... is not XOR, is not equal. Because that's just saying, yeah, these two, they're within a Y of each other, and they're not within an X of each other. I have to check that we're in the same of one and within one of the other. So we'll say if we are within the same X and E.Y plus 1 is I.Y or E.Y is I.Y plus 1. So if we are that, or that with the Y's and X's swapped. Okay, format that please for me, and then test that. And now white should be separated. Yep, white is separated. Okay, now what I want to do is if a adjacency boundary only has one element, so I say let boundary equal get adjacency boundary, and then I say if boundary dot len is greater than 1, then we insert the boundary. Because we don't care about anything that is just on its own. We only care about groups, because groups are what is destructive in their nature. Okay. So, with that found, with those groups found, okay. Okay. Now I'm going to want to do restrictions on some of these pubs, because all I want to expose to the outside world when I publish the library is the action API, which means like all of this get, mute. I mean, maybe get will be legal. Probably get value will be legal, but then nothing else. That'll all be locked down to being just create internal. So now over in my tests, I should be able to say let joueur groups equal this. Okay, and with the joueur groups equal to that, I can say joueur assert ec joueur groups dot len 3. So there should be 3 joueur groups in here. And then I'm also going to assert ec joueur groups dot into iter dot map n dot len dot collect so turn it into the lengths, dot collect that into a vector. I'm going to assert and then let mute list equal list dot sort that. I'm going to assert that the list is equal to 2, 3, 4. In theory. Cargo test. All tests pass. Right. Okay, with that, it is 9 AM. I've been going for 6 hours, but my goal is to get to 10 AM, not 10 AM, 11 AM before I, go to bed. So I've got to ask myself the question, how much further do I take this tonight? Do I, I could go for the full thing and then that'd be cool. But I also don't really want to do that, What am I thinking here? I'm thinking because all I need to do now is get generate the generate the actual harmonies that are there, and then this thing might be done like real soon. Yeah, I'll go for finish. We'll just like whole project one day, and then I'll publish, clean up the what's public and what's not, and make it. Yeah. Okay. So the next thing to do then is in the library we need to implement a method. So this here generated a list of all harmonies. What I want is get a list of all the harmonies. Get harmonies. Vec harmony. And again, there will be allocation here because you need to do inspection essentially. Because you have to have all the harmonies allocated. So unfortunately this here I'm going to immediately allocate, but hey, so let uneliminated harmonies equal self.get get gen uneliminated harmonies. This here is gen harmonies. Let harmonies equal uneliminated harmonies dot play. Right. So we need to take a deep copy, because we have our second copy, our mutable copy that we're going to be eliminating from, and then that's what we're going to be returning at the end. So, okay. Right. Yeah, okay. Okay, so we've got ourselves our harmonies vector. This is public. Generates the full list of harmonies that are not being cancelled. Right, okay. So we can rely on some underlying properties maintained here, which is that they always have a low and a high. Harmonies always have a start and an end, and the start is always lower in whatever axis it moves in. Now the first thing you need to do is you need to go through yeah, so it's, I mean really what you need to do is get your uneliminated harmonies, collect it and clone it, and then do it again? Do I allocate at all in uneliminated harmonies? It's actually a better question. No, I don't. Nowhere. Right, that means actually just calling it twice is probably quicker. For this, I do need to collect it, but then for harmony in self.gen uneliminated harmonies, or rather dot, yeah, okay, so then we can filter this harmony, and then in here we say for other in uneliminated in self.gen uneliminated harmonies. We just call it again. Right, cool. So now we have harmony and other. Collect this into its output form. Okay, and then all we need to do is check if other eliminates harmony. And if it does, we return false, and if it doesn't, we return true. So actually it's self.gen eliminated harmonies.any other in here. And if I set this to false for now, then this is actually just doing the same thing as gen uneliminated harmonies, because it's not going to eliminate any of them. But what we're really interested in is doing that elimination. So I will be back in a minute, and then we can write that elimination function. Alright, I'm back. It's time to do this bit of code, right? Coming up, 6 hours now. Woot woot, right. So, the elimination code. I've written this before, but not in Rust. I don't know how it worked. So, yeah. What we're going to do is we're going to write some helper methods over here. But basically what it's going to boil down to is remember these are copy, so we don't need to do referencing like I normally would. We check if to intersect and then we also have a check if to overlap, or rather is Do we have a fancy word for the two types of harmony elimination? Demonstrated here. Enclosed. So intersects or encloses. So we're also going to want HubFN is horizontal, which lets you know if we are in a horizontal environment, and that is to say start dot now return start dot x extend dot x. So in order to enclose, right, so first of all, in order to intersect, self dot horizontal must not equal other dot horizontal, and here self dot horizontal must equal other dot horizontal. In essence, we check if when intersecting they are parallel, we return false. If when enclosing they are perpendicular, we return false, because that can't be the case and that can't be the case. It just doesn't work. Right. Now, checks if another harmony intersects this one. Checks if another harmony harmony is enclosed by this one. Is enclosed by itself. Closed by self. Checks if. Okay. Right. So I think encloses is simple to write. So once we've established that we are on the same plane, we have to establish which plane. So if we are in horizontal mode, then what we are checking is that other dot x, other dot start dot x is greater than self dot start dot x. Other dot end dot x is less than self dot end dot x. Otherwise, we are checking that other dot start dot y is greater than self dot start dot y, and other dot end dot y is less than self dot end dot y. Done. Enclosement written, I think. Intersection. So for intersection, what we need to check is if does the others... Okay, well, if we are in horizontal, then if we are horizontal, then other is vertical. Then we are checking if self.start.y, which is self.y, is less than self.end.x, and self.start.y, which is self.y, is greater than self. Do it the other way around. That is to say, is y bigger than our start position but less than our end position? Does its height... Wait, no. We are horizontal here, so we care about its x and r and y. So does its lateral position fall within the bounds Wait. If we're horizontal, our y is the same. Aha, I've solved it. Does its x, does its y fall within the boundary of our x? Given that it is at a given height. No. Now all we really ought to check is that does its x fall within our x, surely. We have a span x, it has a single x. Is its x inside our x? Yes. Else, if self.start dot y is greater than self.start dot y and self.start dot y is less than self.end dot y. If we are in a vertical mode, we are checking does its singular y position fall within the bounds of our y. Right. Wonderful. Back over here. We know that we want to display this harmony only if the other does not enclose the harmony and the other does not intersect the harmony. Wait, no, we are cancelled if harmony encloses other. And then these, it doesn't matter which way around they go, but I'll put them this way around for similarity purposes. Because it is if the outer harmony encloses the inner one that we discard. Right. Well, that's remarkably simple, I suppose. I guess I ought to set up this diagram here to inform as to okay, so filling this up in tests. Okay, test gen harmonies. Okay, we're going to make a new 7x7 board. We need to place 1, 2, 3, 4, 5. Well, we need to place 8 coordinates. 1, 2, 3, 4, 5, 6, 7, 8. And our coordinates are 3, 4 for black, 2, 2 for white, 3, 0 for black, 2, 2 for white, 3, 4 for black, 4, 2 for white, 2, 5 for black, 0, 5 for white, 4, 5 for black, 6, 5 for white. This should generate no harmonies. It should generate 1, 2, 3, 4 harmonies that are uneliminated. So what I will do is I will say assert ec board.gen uneliminated harmonies dot count 1, 2, 3, 4. Should be 4. Test. Errors. Okay, that test worked. Now, we should assert that there are 0 legitimate uncancelled harmonies. It's still believed there to be 4 harmonies. Filter, where any, also implement iterator item harmony. Congrats, I just solved the allocation going on in here, I guess. Restrict the lifetime of that. Okay. Move here. Move here, question mark. That might break it. No, it didn't. Wonderful. Okay. If the harmony encloses the other, or is intersected by the other, then we are false. Else we are true. Ooh, okay. A point of order. No, of course it can't. It's still being in a position to create 4 harmonies is confusing to me. We're on the point of count now. For I agree that it's no. So gen harmonies, they should be eliminating. Why are they not? In here, we say filter the harmonies such that if any other harmony does filter expect true to remove or true to persist? So that makes a big difference. Filter. If the closure returns true, then the element is returned. If the closure returns false, it will try again. Having inverted it, oh, well, yes, of course, there should be a single harmony. So here we say filter it for any harmony that is enclosed or intersects. Well, I can't argue with the... Does this return true? Really? Well, this isn't... yes, well, I suppose. Oh, well, we are filtering for anywhere it is true, therefore it must be this way around. That makes perfect sense, and of course there is a single harmony. I'm blind. Okay. Now let me go to the tests. This is a single harmony. And it is black's turn. Black will, of course, play at 3-6, which we might expect to increase this by 6 and this by 1. Of course, we are not checking that the two harmonies are of different origin. So we filter if there is harmony, color, and we want to specify it as if they are not equal. Am I perhaps wrong again? We want anywhere. We want to filter any where the harmony and the other harmony are of different color. The harmony encloses the other, or the harmony encloses the other or intersects with the other. Tests. Position of 3-6 should provide an additional harmony here. Yet it is not. And that is peculiar. Most peculiar. It does agree that we are now of 6 harmonies, so it is connecting this and this. It is connecting... The stone I have proposed placing is to place a stone here, which adds an additional harmony here and here, but should not add any new eliminations. Doing this would obviously result in it saying 0, ideally. Interesting. This value does not change what it supposes to be the case here. It supposes there to only be one harmony either way. As if it is not properly acknowledging the new harmony. Okay, what's it finding? It's finding the harmony from 0, 5 to 6, 5. Oh, well, that isn't a legal harmony at all. Perhaps the original legal harmony was wrong. Well, that supposes that the enclosing logic is incorrect. I'm stating that if the harmony encloses the other, it should be filtered. We enclose if the other is greater than us pretends before us. Oh, I must check that they are the same. other.start.x is equal to other.start.y is equal to other.end.y, and the following. Other.start.x is equal to other.end.x and the following. Now I suppose it should run. Right. If we're in horizontal mode, then we must say that our y values are the same to be considered an enclosement. For if the y values are not the same, then nothing else really matters, does it? They can't enclose. Likewise for these x values. Up here I have to make no such check. Or do I? Well, of course I do. Here I'm saying that if we are horizontal, then their start x. Right, yes, but also why is it entirely referential to the other? Then their start x must be greater than our start x, and in addition to that, their starting y position which for them is a genuine thing. Oh, well, I suppose it's actually quicker to simply say yes, we say and first of all, we'll remove this for now. Not only is their starting x position, I need to draw a valid and invalid intersection on some paper to wrap my head around it temporarily. So the instance of validity is one such that their starting x position, if we are to be considered the horizontal one, then their starting x position, which is their x position. Let us clear the misnomer by simply saying this. Let other x equal self.start.x. Let other y equal, let self y equal self.start.y. Then we are to say that the other's x position comes after the beginning of ours and before the end of ours, and it is such that our own y position is greater than the beginning of their y, and our own y position is less than the ending of their y. Other y, y, x, x, other y, 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 x, 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 x. Format. Test. Excuse me. The harmony from 0, that is the only harmony it is detecting. Okay. We must eliminate the new changes and deliberately cause a panic in order to check uneliminated run that. Collect them both into vectors. Right. Take this into a notepad to contrast with this here. The uneliminated harmonies, which we will draw in red, in purple, it identifies fall from axis 3 0 to 4. Thus it correctly identifies this harmony as black. It also identifies 2 2 to 4 2, this harmony here. It also identifies 0 5 2 6 5 for white, 2 5 2 4 5 for black. Wonderful. And after elimination it detects 0 5 2 6 5, which is of course incorrect. It is due to the enclosures rules that must be incorrect, so I will review them. In order to enclose, allowing us to be horizontal, self y is equal to we share the same. If we are horizontal, then it is for we share the same y coordinate. Okay. So, first of all, self y must be equal to other y for us to be the outer enclosing. Then it is such that the other start x must be greater than our own start x, and the other's end x must be less than our own end x. Here we simply need to swap x's and y's. In our library, we say we are going to filter. Anywhere we enclose the other, or we intersect the other. It is in the only... Okay, so it is simply that our enclosures logic is somehow wrong. When calling it like this, so to say that we would like it to be true that a harmony encloses another harmony, yet it's currently acting as if it is enclosed by. Encloses states that their starting position is greater than our starting position and their ending position is lesser than our ending position. Thus, they are enclosed within us, not the other way around. Here we suppose that their y position greater than our y position. Their y position falls within the boundaries of our y positions, and our x position falls within the boundaries of their x position. I think there's something fundamentally wrong with the structure here. We wish to filter anything where we are able to detect a problem. We should not be filtering. Harmony encloses other. So this now should be true to reject. In order to reject, harmony must be the colors of the harmonies must differ. The harmony must enclose the other or intersect the other. Well, it believes there to be 3 of them now, and it brings me a great deal of annoyance. Which 3 does it believe exist? It believes correctly that exists. Okay. Here intersects. If we are both horizontal or both vertical, we cannot intersect. In horizontal mode, we are horizontal, which means we have a unified y, and they have a unified x, as we know that they are not horizontal. So for their x position, it must come after the start of our y. Must come before the start of our x, but must also be before the end of our x, and our own y must fall within the boundaries of their y. That is correct. yxx, yxx, yx, yx. Very well, this is also correct. So let's work it through. Let's see how exactly which one do we lose? That's a better question, because we are losing. We keep 2 5 4 5. And we keep the 2 intersecting black harmonies, yes. We keep 2 2 4 2. And we keep 3 0, yes. Okay, so the intersections are incorrect. This should return true if they intersect, by my understanding. Right, well, we're saying that the others starting x is greater than our starting x, and that the others finishing x is greater than our starting and then our finishing x. We are claiming that our own beginning y is greater than their beginning y, and that our own ending y is lesser than their ending y. Now in reverse, where we are this, we're checking that they begin other.start.x, that they begin after we... Okay, no, that is why this is incorrect. If we are horizontal, then what we know is that self.start.x self.end.x is greater than other.start.x, and self.start.y must be greater than other.start.y, and self.start.y must be less than other.end.y. And for false true, for they are in the vertical mode, no, for we are in the vertical mode, then we know that they intersect if our own starting x position, we are vertical, thus we have a single x, is greater than their starting x position. Our starting x position, which is our x position, is less than their ending x position. Our starting y position is less than their starting y, and our starting y position. So we've got left, right, right, left, x, x, y, y, start, 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 end, start, end. We care that our ending y is greater than this, so we've got end, start, 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 end, start, start. We want our starting x to be Good, that worked. Remove the explicit panic and it passes. Right? Okay, that change worked. Now we need to, well, add a new black piece. I was going to add it here, which is at 3, 6. It should increase these numbers to be 6, 2. Two 5 to 4 5. Oh, well, of course, because that's intersected by that. Now white is going to play 6. Six 2. And that is going to give another 2 of these and 2 of these. No, of course it's going to give another 3 of these because it adds the broken harmony as well as the valid one, but it only adds another 2 legal ones. Correct? And then lastly I will place one at for black at 6 0, which should add 1 more harmony only, but it is a legitimate one, so 10 4, I believe. Okay, harmony detection works. It is quite a nice bit of code actually. The only slowness comes from the only like nice thing in this entire thing comes from our detection of Zwisch groups. The actual code for generating the harmonies is remarkably clear. If there's any instance of there be 2 harmonies being the same, the harmony enclosing another harmony, or it intersecting a harmony, then we eliminate it. Okay. With that, we have a means of detecting if a given harmony. We have to detect if a stone. Oh, if a stone is part of a harmony, that's got a. Yes. No, I should add a Zwisch in here because a Zwisch does generate a harmony. It just is going to be ignored most of the time. So I'm going to place one at 4 3 in our tests. And a piece at 4 3 should result in 4 3. We'll add a single uneliminated, a single one of these, but before it we can assert that there is get groups dot len would be 0, and after that we have a single group. Okay, that worked perfectly. Right, in that case, I'm ready to finish movement and elimination. Well, movement I need to have a... Well, no, you just check if you're at the start or the end of harmony. Right. Is there any other situation where you might be on a harmony but not a part of a harmony? I don't believe so. Right. So, act move needs to check that you are a member of a harmony. So to do this, what it's going to do is it's going to do board dot gen harmonies dot any harmony and then we say from equals self dot harmony dot star dot it equals harmony dot start, or from is harmony dot end. So if it is none of those things, then we return an error, act from to error, target not on harmony. Oh, and we also have to check our color, which means that this is a better thing to do after we know our color. If to move okay. The target stone does not have a harmonic line to move on. Cannot board as immutable because it also board as mutable. Up here to get mute. Okay, so it's time to test stuff. You know what? That might be the full client, to be honest. Oh, we have to implement elimination. Right, elimination's easy, because all it is we come to here. We come to commit. Commit applies the action. Okay, and then after the action is applied, after the action is applied, we returns the number of removed stones. Okay. So now what we have to do is say 4 stone in okay. Can a jury group survive on its own is a question of can so we do let mute has been death equal to, don't bother with that, loop, right. Break. Okay. So we know the we can use break to exit if needed. So if right. So while we loop, we are going to process death. Now death determines the no. In order for death to take hold, we need to know the removal precedency. And so what we need to do is in our act here, we have suicide, no, capture or suicide first. So capture first, or suicide is fn capture first self, which returns a bool. No, it is static. Then for move, we capture first. For placement, we suicide first. Okay. Now in our library. Okay. Now if we look at the specification once more, you'll notice removal. Dead stones are removed. If the player placed a stone, their own coloured stones are removed first. If the player moved a stone, the enemy stones are removed first. When removal is happening, stones with colour being removed are inspected. If they are on an enemy harmony, they are dead and removed. Next, the opposite colours are checked. Dead stones are removed. If any stones are removed, this step is repeated to allow for chain reactions. Okay, so we have to, in our commit up here, we must reach both. We must perform both actions. So okay, well, perhaps we ought not do this. Perhaps we ought to just write the rest of our code in here. Okay, that is correct. So, we want to do this before we change the active player. Of course, we want to do all the deaths. So, we say, let target equal, let mutable target equal, self.activePlayer. Let deaths equal false. Let death no loop. Okay. So if A capture first, so if we are to capture first, then we set our target to be the other player. Right. Well, if the target is... No, we need all stones. For a... We need just all the stone locations. Well, we do that in here, don't we? I can call this generates the location of each black and white stone. Of course, the first time we commit, it breaks. Let me put an immediate break in here. To allow for immediate testing. Yes, okay, perfect. So, if we generate stone locations in here, right. Well, we need a map from stone to. But black white equal gemstone locations, self dot gemstone locations. Okay, after generating stone locations, okay, if target is black, let target stones equal, if target is black, black, else white. This could be much cleaner expressed as match target black to black, white to white. Much nicer to read. Okay, so we know what our target stones are, because we generated all of the locations of all of the stones. Now, knowing the locations of the stones and knowing which stones we are targeting, we can say for stone in target stones, if oh no, first we should do we're to build up the set to remove, of course. So let ut to remove equal hash set new. We'll simply be pushing into this to remove, and then we'll be removing at the end. So if stone in target stones, if for harmony in self.gen harmonies, if harmony dot start is stone or harmony end, I do need a liaison. Checks if the harmony encloses a stone. Pub fn encloses stone self other harmony self other location bool. If self dot horizontal, will my own y be my starting y? Say self y is start dot y, self y is other dot end dot y. If self y is other y, and self dot x start dot x is less than other dot x, and self dot start dot end dot x is greater than other dot x, else self x x x x y y y y. If harmony encloses stone stone, so if at any point a harmony encloses a location, harmony encloses the location and the current value of our location. Okay, so we get our Jouer groups. Okay, so each 0th harmony group is a hash set of locations. Now, now here's the thing we have to do. For each Zwish group, so we have a group now. We have to create a clone of, so we say let virtual board equals self.clone. Okay, so we have a virtual board. Now our virtual board, we now have to unset things on. So we have to say for stone in Jouer group dot I need to check how hash sets work notationally. Can I take a single element from a hash set, or do I have to take a hash set from a hash set? Difference. Okay. Okay. Yes, so we need to also create a clone of the Jouer group. And that is to say we iterate over a clone of the Jouer group, because we need to look at every element of it. We'll say let virtual group equal Jouer group.clone. Now for each stone in our outer we say our virtual, we say for each stone in our virtual group, group dot Okay. I want each permutation that doesn't include one of the elements. Well, I suppose it's just taking without the stone. So for each stone in visual group we're closed, we say virtual group dot remove you can remove from hash sets, and the value we're removing is stone. Okay, right. Well, that just removes every stone from the virtual group. No, it doesn't. Yeah, it does. No, what we do is we say for stone in zero group iter self dot unset value location. So this here removes the entire zero group. And when it is done removing the entire zero group, we have to do this for add location in zero group iter. Remove the entire zero group. Self.set value. Add back in a location. And the value we are setting it to is the value of what it was removed, and we are... Well, get to a group doesn't care about the color, does it? Perhaps it should. Perhaps I should give back 2 hash sets. No, I like it giving back a full list. I'll just find out what color was being removed. We say let color equal self.getValue add location unwrap fine because unwrap. You know what? Rather than unwrap, we will do dot unwrap or else unreachable. Okay. So because get value should always return a location that's valid. Because sorry, the ZWH group should always only have locations that are valid. Now, we don't do this stuff on our virtual board. On the virtual board, we then reintroduce that location. Okay. FN eliminate stones. Target color stone. We return a hash set of stones to eliminate. No. Stop that. Right. For each add location, we add that location back in. Okay. And then we say if on the virtual board moves the virtual board, mutable virtual board. We clear the virtual board. Then for every location we come across, remove it from the virtual board. Reintroduce the desired stone. Check if that stone should be removed. Okay. And then if it should be removed, if and only if it should be removed. If it should be removed, we don't just remove the add location. We say to remove dot do we have the union operator to remove union? Visits the values in the union. All the values in self and other out. To remove. Right, well, we just say for location in joueur group. And we can then, of course, short circuit the that group. So this here is the joueur group. Okay, for location in joueur group. To remove dot insert location. Continue. Also known as, hey, move on to the next group, because we've established that there is a group in here that we've established that one of the locations results in all of them dying, therefore we don't need to check all the others, we can just move on. Okay. So that happens then there. Right. So we do this for everything. Okay, we come down here. We come down to the end of this loop and we say if to remove is empty, which is to say that there has been no change at all so here we can say remove mute, remove progress is 0. If it's empty, then we can say remove progress plus equals 1. To remove, if remove progress is 2, we can break the loop. Else, remove progress goes back to 0, because it has to make it through empty twice, once for each player. And then it sets the target color to be the inverse target color. Right. I need to write tests, but it's probably done. Okay. What's happened? Which one is the disk? Okay, good. Build. Wonderful. Right. So then it would come down to testing. Now, I could do the rest of the testing with more test statements. But at this point, it's going to... I've been streaming for 7.5 hours, and it's going to be easier to do the testing by building an interface and playing some game. So, I'm going to come back probably soon, but who knows with my exams and such, and do just that. Playing game by interface. But the library has made huge progress today. Thank you all for watching. It's been a good stream.